In the profound, silent darkness beyond the furthest known planets, a solitary human voice has been speaking for nearly half a century. A whisper across billions of miles, carried on the faintest of radio waves, sent by a machine that is a testament to our curiosity. This is the story of Voyager 2, our silent emissary to the stars, a ghost ship sailing the cosmic ocean far from its home port. For decades, its transmissions have been a steady, predictable heartbeat, a stream of data from the interstellar void, familiar and comforting to its creators. But recently, that familiar heartbeat faltered. A new message arrived, a strange signal that was unlike anything heard from the probe before. It was a puzzle broadcast across the solar system, a deviation in the data that has sent ripples of intrigue through the scientific community. What is our oldest active explorer trying to tell us from the darkness? What does this unexpected transmission from Voyager 2 truly mean? To understand the signal, we must first understand the journey. A voyage that began in a different era, a different technological age. Launched in 1977, Voyager 2 was designed for a 5-year mission to study only Jupiter and Saturn, a grand but limited planetary tour. No one predicted it would still be operational today, having flown past Uranus and Neptune, becoming the only spacecraft to visit all 4 giant outer planets. It carries with it the golden record, a time capsule of Earth's sounds and images, a message in a bottle thrown into the cosmic sea. Now, over 12 billion miles away, it drifts in interstellar space, the region between the stars, a place no human creation had ever touched before. At that distance, a command from Earth traveling at the speed of light takes more than 18 hours to reach the spacecraft. Its reply, its faint whisper carrying the data, requires another 18 hours to complete the journey home, a full day and a half for a single conversation. The power of its transmitter is merely 23 watts, the same gentle output as a refrigerator light bulb, yet it bridges an unimaginable gulf. To hear this faint signal, we use the massive ears of the Deep Space Network, giant radio antennas positioned strategically across the globe. For years, the data stream has been consistent, measuring the charged particles and magnetic fields of a realm far beyond our sun's influence. But the recent signal was different. It was not a language, not a picture, but a corruption in the telemetry, a series of phantom data points. The spacecraft's attitude articulation and control subsystem, the system that keeps its antenna pointed toward Earth, began sending gibberish. This was not an alien message, but something perhaps more concerning, the potential sign of a machine finally succumbing to the cold rigors of deep space. The signal was a ghost in the machine, a flicker in the consciousness of our most distant robotic mind, and Mission Control had to understand why. Was it a hardware failure? A component finally freezing and cracking after decades of service in the absolute cold of interstellar space? Or was it a software glitch, a single flipped bit in its memory caused by a high-energy cosmic ray, a random bullet from a distant supernova? The team on Earth faced a profound challenge. How do you troubleshoot a computer from the 1970s when it is 12 billion miles away? The stakes were incredibly high. If they lost the ability to aim Voyager's antenna, the faint whisper would be lost forever in the background noise of the cosmos. The mission would effectively be over. Our connection to the interstellar medium, our only direct line of evidence from that region, would be severed. The Voyager team is a group of dedicated engineers and scientists, some of whom have spent their entire careers listening to these probes. They began a painstaking process of diagnosis, sending commands and patiently waiting a day and a half for the results of each test. It was a slow, methodical conversation with a machine across an ocean of space and time, trying to coax it back to lucidity. The strange signal was not a message from elsewhere, but a cry for help from one of our own, a faltering of an old and faithful servant. Consider the environment Voyager 2 now endures. It is a realm of cosmic radiation, far from the protective magnetic bubble of our sun. The systems on board were not designed for this. They are pioneers in a harsh and unforgiving frontier, constantly bombarded by energetic particles. The mystery of the signal became a race against time, a desperate attempt to fix a problem with tools and commands designed 4 decades ago. The engineers pored over old documentation, schematics from a bygone era of computing, trying to understand the mind of their distant machine. The breakthrough came from a simple, elegant idea. They would try to reset the specific part of the computer's memory that was causing the issue. A command was carefully crafted, a packet of information containing the digital equivalent of a hopeful prayer, and beamed into the void. Then came the long wait. 36 hours of silence, where the fate of this historic mission hung in the delicate balance of a few lines of code. The world continued, unaware of the quiet drama unfolding between a control room in California and a tiny probe in the interstellar dark. The team waited for the signal's return, hoping the telemetry would be clear, coherent, and stable once more, a sign their fix had worked. This strange signal is a reminder that space exploration is not just about discovery, but also about endurance, resilience, and ingenuity against impossible odds. It highlights the profound connection we have with these robotic explorers, extensions of our own senses reaching into places we cannot yet go ourselves. So what did the return signal say? Did the reset work? Did humanity's most distant outpost resume its steady, familiar heartbeat? The resolution to this deep space mystery is a story of incredible technical skill and a testament to the durability of this legendary spacecraft. The strange signal was a brief moment of confusion, a temporary hiccup in a mission that has defined the very edge of human exploration. The tale of Voyager is a continuous epic, and this chapter, The Mystery of the Garbled Data, adds to its rich and ongoing legacy. The probe continues to sail onward, its instruments still dutifully tasting the stellar winds that blow between the stars of the Milky Way. Its power source is fading, and within a few years, its instruments will fall silent one by one, ending its scientific mission forever. Yet its journey will not end. It will drift silently for eons, a human artifact in the cosmic wilderness, waiting to be found. This recent event was not the end, but a powerful reminder of the incredible fragility and astonishing resilience of our first steps into the galaxy. Now, let us delve deeper into the precise nature of the problem, the elegant solution, and what this event teaches us about our future in space. After 36 hours of tense anticipation, the response arrived. A clear, precise stream of telemetry flowed back into the Deep Space Network's receivers. The digital gibberish was gone. The Attitude Articulation and Control Subsystem, the AACS, reported a nominal status. Voyager's high-gain antenna was once again perfectly locked onto the faint signal of its home world. The reset command, a carefully aimed digital scalpel sent across the void, had successfully excised the corrupted data from the system's memory. For the mission controllers, it was a moment of profound relief and quiet triumph. They had not just saved a mission, they had reaffirmed a connection to a piece of humanity that has traveled further than any other, a testament to our ingenuity across unimaginable distances. To appreciate the elegance of this solution, one must first understand the heart of the problem: the AACS. This system is Voyager 2's autonomous navigator and pilot, a complex network of sun sensors, star trackers, gyroscopes, and tiny hydrazine thrusters. Its primary function is to maintain the spacecraft's orientation in three-dimensional space with incredible precision. Without it, the main antenna would drift, and the priceless data stream would become an aimless, unheard whisper lost in the cosmic static. The AACS must know exactly where Earth is at all times, a moving target in a vast celestial sphere. The strange signal indicated this fundamental sense of direction had become corrupted, as if the probe were struck with a form of digital vertigo, a critical failure in the most hostile environment imaginable. The prime suspect for this digital ailment was a single-event upset, a phenomenon common in the harsh radiation environment of deep space. The cosmos is not empty. It is permeated by a constant flux of high-energy particles, known as galactic cosmic rays. These are the shattered remnants of atoms, accelerated to nearly the speed of light by cataclysmic events like supernovae. When one of these microscopic bullets strikes a sensitive component like a memory chip, it can deposit enough energy to flip a single binary digit. A 0 becomes a 1, or a 1 becomes a 0. In a complex string of code that governs a spacecraft's orientation, one flipped bit is all it takes to turn coherent commands into the nonsensical data that created the phantom signal. The engineering genius of the Voyager probes lies in their remarkable resilience to such events, a resilience born from the design philosophies of the 1970s. Lacking the sophisticated error-correcting software of modern spacecraft, Voyager's designers relied on redundancy and robust, hardened electronics. The computer systems are ancient by today's standards, with less memory than a modern car key fob. Yet, this simplicity is also a strength. Their code is lean, and their components are large, making them less susceptible to radiation damage than today's microscopic transistors. The fact that a simple memory reset could fix the problem, without any lasting physical damage, is a stunning validation of that original design philosophy. The probe simply needed a reboot, a task of immense complexity from 12 billion miles away. The command sent to reset the AACS memory was itself a work of technical artistry. The engineers could not simply send a generic restart signal, as that might disrupt other critical systems. They had to pinpoint the exact memory addresses where the corrupted data was stored and issue a poke command, a term from early computing, to overwrite that specific block with correct default values. This required an intimate knowledge of the 40-year-old software architecture, gleaned from decaying paper documents and the institutional memory of long-serving team members. The successful execution of this command across an 18 light-hour delay is one of the great, unsung achievements of deep space operations, a triumph of precision and patience. This event underscores a fundamental reality of interstellar travel. The journey itself is the primary adversary. Voyager 2 is no longer exploring planets. It is exploring the very nature of space between the stars. It is our first and only direct sensor in the enigmatic region beyond the heliopause, where the solar wind from our sun finally gives way to the true interstellar medium. The data it sends back is rewriting our understanding of the cosmic environment, measuring the density of particles, the temperature, and the strength of the galactic magnetic field. The strange signal was a stark reminder that if we lose this link, we lose our only eyes and ears in this new frontier. Preserving the spacecraft is now the mission itself. The power source for this incredible journey is a radioisotope thermoelectric generator, or RTG. It functions as a nuclear battery, using the heat generated by the natural radioactive decay of plutonium-238 to produce a steady supply of electricity. When Voyager 2 launched, its RTG produced about 470 watts of power. Today, after more than 4 decades of decay and thermal degradation, that output has fallen to just over 200 watts. This diminishing power budget is the ultimate arbiter of the mission's lifespan. Mission planners must make difficult choices, shutting down non-essential heaters and instruments one by one, carefully rationing every last milliwatt to keep the probe's voice alive for as long as possible. The recent anomaly with the AACS forced engineers to reevaluate their power-saving strategies. To prevent a recurrence, they identified a non-critical system that was drawing a minute amount of power but was also connected to the same circuit as a key AACS voltage regulator. By sending a command to permanently shut down that other system, they could provide a more stable power supply to the crucial orientation hardware, reducing the likelihood of future glitches. This is the delicate dance of managing an aging spacecraft, a constant process of optimization and sacrifice, trading one capability for another to extend the mission's life by another day, another month, another year. It is a slow, graceful power down of our greatest explorer. So what does the strange signal truly mean for the future? It means that Voyager 2 is becoming more fragile. While the problem was solved this time, the incident serves as a premonition of the challenges to come. As the power dwindles and the components age under the ceaseless bombardment of cosmic rays, anomalies like this will likely become more frequent. Each one will present a new and more difficult puzzle for the team on Earth to solve across the light hours. The strange signal was not an ending, but a transition into the final, most delicate phase of the Voyager mission. It is a phase defined not by grand planetary flybys, but by the quiet, tenacious struggle to keep a faint voice from being extinguished by the immense silence. The legacy of Voyager is not just in the data it collected, but in the profound perspective it has given us. It was Voyager 1 that turned its camera back toward home in 1990 to capture the iconic pale blue dot image, a single pixel of light in a vast sunbeam. This photograph fundamentally shifted our perception of our place in the cosmos. Voyager 2, through its continued operation and its recent brush with silence, provides a different kind of perspective. It shows us the sheer tenacity required to maintain a presence in that vastness. The strange signal was a crackle in the line, a momentary disruption that reminded us just how precious and tenuous that cosmic connection truly is. The incident also brings renewed focus to the other passenger aboard Voyager 2, the Golden Record. This phonograph record, fashioned from gold-plated copper, is a message in a bottle cast into the cosmic ocean. It contains 115 images of life on Earth, a collage of natural sounds, greetings in 55 languages, and a selection of music from Bach to Chuck Berry. It is a capsule of human culture, a greeting card to any civilization that might one day find it. The recent signal anomaly was a poignant reminder that while the probe's scientific mission is finite, its cultural mission as a silent, drifting ambassador for humanity will last for eons, long after its power has faded and its voice has gone quiet. The spacecraft is currently moving at over 34,000 miles per hour relative to the Sun, but even at this incredible speed, space is incomprehensibly vast. It will be approximately 40,000 years before Voyager 2 comes remotely close to another star, passing within 1.7 light-years of a small red dwarf named Ross 248. By then, its nuclear battery will have been cold for millennia. It will not see that star, or any other. Its destiny is to drift in the quiet darkness of the Milky Way galaxy, orbiting the galactic center roughly once every 225 million years. A silent testament to a species that once looked up at the stars and decided to go. Thinking about Voyager's resilience puts modern space technology into perspective. A contemporary probe like the James Webb Space Telescope has multiple, redundant, and vastly more powerful computer systems, with sophisticated error detection and correction codes that can instantly fix flipped bits from cosmic rays. Voyager has none of this. Its survival depends on the robustness of its 1970s hardware and the deep knowledge of its human operators. This strange signal event was a masterclass in deep space forensics, a feat of engineering that relied more on human intellect and understanding of an archaic system than on any automated protocol. It was a human solution to a machine's problem, bridging a technological gap of half a century and a physical gap of billions of miles. The human element of the Voyager mission is perhaps its most overlooked and vital component. The team is a small, dedicated group of engineers and scientists at NASA's Jet Propulsion Laboratory. Some have been with the mission since its inception, their entire careers interwoven with the trajectory of these twin spacecraft. They are the keepers of the flame, the translators of Voyager's faint whispers. They understand its quirks and idiosyncrasies as one might understand an old friend. When the strange signal arrived, it wasn't just a technical problem. It was a personal one. Their ability to diagnose and fix the issue is a testament to the power of long-term dedication and the irreplaceable value of human expertise in an increasingly automated world. The time delay involved in communicating with Voyager 2 forces a unique state of mind. At a round-trip light time of over 36 hours, there is no real-time control. Every command sent is an act of faith, a carefully considered move in a celestial chess match where you only see your opponent's response a day and a half later. This enforced patience cultivates a deep, methodical approach to problem-solving. It removes the impulse for quick fixes and demands a thorough understanding of all possible outcomes before a single bit is transmitted. The strange signal saga was a perfect example of this slow, contemplative dance with the cosmos, a conversation paced not by human impatience, but by the fundamental speed limit of the universe itself. The science that Voyager 2 is still conducting is groundbreaking. Before it crossed into interstellar space, its instruments detected the complex, turbulent boundary layer of our solar system, the heliosheath. It discovered that the Sun's magnetic bubble, the heliosphere, is not perfectly smooth, but is a frothy, dynamic region filled with magnetic islands and energetic particle traps. Now, in the interstellar medium proper, it is providing our first direct measurements of this unexplored territory. It is tasting the composition of the galactic gas and measuring the force of the magnetic fields that thread through the arms of the Milky Way. Every packet of data is a dispatch from a truly new world, fundamentally altering our models of the galaxy. This glitch was specifically in the telemetry modulation unit, the part of the system that encodes the science and engineering data into the radio wave that is sent back to Earth. When the flipped bit corrupted the AACS data, the modulation unit didn't know how to properly encode it, resulting in the garbled signal. This illustrates the interconnectedness of the spacecraft's systems. A single error in one small part of the flight software can have cascading effects, creating a puzzle where the source of the problem is masked by the symptoms it creates downstream. Unraveling this required the team to work backward from the corrupted signal, tracing the data flow through the spacecraft's architecture to find the single, microscopic point of failure. It is worth remembering that Voyager 2 accomplished all of this on a trajectory made possible by a rare planetary alignment that occurs only once every 176 years. The Grand Tour allowed the spacecraft to use the gravity of each giant planet to slingshot it toward the next, saving fuel and time. This celestial billiard shot was calculated with slide rules and early computers, a masterpiece of orbital mechanics. This context makes its continued function all the more remarkable. It is a machine from a different era of calculation and technology, which not only completed its original, ambitious mission perfectly, but has continued to function for decades beyond, far past the limits of its original design, and into a realm its creators could only dream of reaching. The strange signal from Voyager 2 was not an isolated incident in the history of the mission. Both Voyager probes have encountered numerous challenges over the decades. Thrusters have become stuck, receivers have failed, and instrument platforms have seized up. In each case, engineers on Earth devised ingenious workarounds, writing new software patches, finding clever ways to use backup systems, or simply learning to live with a diminished capability. The story of Voyager is a continuous narrative of problem and solution, of decay and brilliant repair. This recent anomaly is simply the latest chapter in that long and epic struggle, a story of human ingenuity against the inevitable entropy of the universe. Beyond the technical details, the Voyager 2 signal anomaly serves a deeper, more philosophical purpose. It recaptures our attention. In a world saturated with information, it is easy to forget that we have a functioning emissary in interstellar space. These moments of crisis, these strange signals from the dark, pull our collective consciousness back to the edge of the solar system. They remind us of the scale of the cosmos and the audacity of our attempts to explore it. They force us to contemplate the incredible journey of this small machine, sailing alone in the dark, and to feel a renewed sense of connection and awe for what it represents, the very best of our curiosity. Let us contemplate the environment through which Voyager 2 now travels. The interstellar medium is not a perfect vacuum. It is a tenuous plasma, about 1,000 times less dense than the best vacuum we can create in a laboratory on Earth. It is threaded with magnetic fields and populated by atoms forged in the hearts of long-dead stars. This is the very substance of the galaxy, the raw material from which new stars and planets will one day form. Voyager 2 is, in a very real sense, sailing through the ghost of ancient suns and the seeds of future ones. Its instruments, designed to study planets, are now repurposed as galactic meteorological tools, taking the pulse of the Milky Way itself. The successful recovery of Voyager 2 also provides invaluable lessons for future interstellar missions. Any probe we send to Alpha Centauri or beyond will face these same challenges over much longer timescales. It will need to be incredibly autonomous, capable of diagnosing and fixing its own problems. It will need radiation-hardened systems far beyond what we currently possess, and a power source that can last for centuries. The ongoing experience of nursing the Voyager probes through their old age is our first, crucial lesson in interstellar engineering. The strange signal wasn't just a problem to be solved, it was data, teaching us how machines fail in the interstellar void and how we might build their successors to endure. The concept of the signal itself is profound. The radio waves carrying Voyager's data are a form of light, traveling at the ultimate cosmic speed limit. Yet even at this speed, the universe is so large that the message takes the better part of a day to reach us. This delay is a physical manifestation of our isolation. It is a constant, humbling reminder of the gulf that separates us from our creations and from the rest of the cosmos. When we hear Voyager's signal, we are not hearing the probe as it is now, but as it was 18 hours ago. We are, in effect, listening to a voice from the past, a technological echo from the edge of the sun's influence. The very existence of this signal is a triumph over the inverse square law, a fundamental principle of physics. This law dictates that the strength of a signal decreases by the square of its distance from the source. At Voyager 2's current distance of over 12 billion miles, its 23-watt signal has spread out and weakened to an almost unimaginable degree. The amount of energy collected by the massive antennas of the Deep Space Network is infinitesimal, less than a billionth of a watt. That we can detect this whisper at all, let alone reconstruct its complex data, is a miracle of modern radio astronomy and signal processing. It is like hearing a single pin drop in the middle of a roaring ocean. The strange signal was, in essence, a moment where Voyager 2's memory became untethered from reality. The flipped bit created a false set of coordinates for its orientation, a phantom world in its digital mind. The reset command from Earth was an act of retethering, a message sent across the void to say, "No, this is where you are. This is where home is." This interaction feels almost metaphorical. It speaks to the human need for orientation, for knowing our place in the universe. In saving Voyager 2 from its digital confusion, we were, in a small way, reaffirming our own place, maintaining our most distant anchor in the cosmic sea. Consider the sheer loneliness of Voyager 2's existence. It has not seen a solid body up close since it flew past Neptune's moon Triton in 1989. For more than 3 decades, its view has been one of unchanging, distant stars. It is a solitary traveler in an endless night. Its only connection, its only tether to its creators and its home, is the faint radio signal it maintains. The threat of losing that signal is the threat of absolute severance, of consigning our emissary to a truly lonely fate. The successful repair was more than a technical achievement. It was an act of refusing to let our creation drift away into oblivion, an affirmation of connection against the vast indifference of space. The plutonium that powers the spacecraft has a half-life of 87.7 years. This means that by around 2065, half of the original fuel will have decayed. However, the mission will end long before that. The ever-decreasing heat output means that by the mid to late 2020s, there will not be enough power to operate even a single scientific instrument. The final commands will be sent, shutting down the science payload to conserve the last remaining power for the transmitter alone. For a time, it might continue to send a pure carrier signal, a simple dial tone across the void, just to let us know it is still there. Then, one day, that too will cease. The twin spacecraft Voyager 1 and 2 are traveling in different directions. Voyager 1 is moving faster and is further away, heading north out of the plane of the solar system. Voyager 2 is heading south. Together, they are providing a three-dimensional perspective on the Sun's interaction with the galaxy. The data they send back is not identical. It reveals the asymmetries and complexities of the interstellar boundary. They are like two scouts sent in different directions from a great expedition, reporting back on the nature of the undiscovered country that lies just beyond the borders of our own territory. The strange signal from Voyager 2 threatened to blind us in one of those crucial directions. The language Voyager 2 speaks is assembly, a low-level computer code that is incredibly efficient but difficult to write and debug. The engineers who work on it today are like digital archaeologists, interpreting and modifying a language that is no longer taught. Sending the reset command was not a simple matter of typing and clicking. It required a deep, almost intuitive understanding of how the machine thinks. It is a skill honed over decades, passed down from one generation of the Voyager team to the next. The preservation of this knowledge is as critical to the mission's continuation as the hardware on the spacecraft itself. It is a living link to the dawn of the space age. The strange signal event has a beautiful symmetry, with the purpose of the golden record. The signal was an unintentional, corrupted message from the machine itself, a sign of its aging process. The golden record is an intentional, carefully curated message about its creators. One speaks of the fragility of technology and the rigors of the cosmos, while the other speaks of the resilience of life and the hope of connection. Together, they tell a more complete story, that of a hopeful but fragile species, reaching out from their small blue world, sending both their art and their fallible machines as emissaries into the grand, silent expanse of the galaxy. Let us be clear, this was not a sign of the spacecraft's imminent death. It was more like a symptom of old age, a momentary confusion that was corrected with care. The probe's core systems remain functional, and its power source, though diminishing, is predictable. The mission team expects to get several more years of valuable scientific data from the interstellar medium. The incident, however, has recalibrated expectations. It has reminded everyone involved that Voyager 2 is living on borrowed time, a priceless artifact that requires ever more gentle and careful handling. Each day of new data is a gift, a bonus chapter in one of science's greatest stories of exploration. The magnetic field instrument on Voyager 2 is one of its most important remaining senses. As it travels, it measures the direction and strength of the galactic magnetic field, a vast and complex structure that shapes the evolution of the Milky Way. This field is the invisible architecture of our galaxy, guiding the flow of cosmic rays and influencing star formation. Voyager's data has revealed that the field just outside our solar system is stronger and more dynamic than models had predicted. This is frontier science of the highest order, made possible only by a 40-year-old machine and the team that has learned to coax it through the challenges of its final years. Imagine the moment, perhaps tens of thousands of years from now, when the golden record might finally be intercepted. An alien intelligence would find a silent, inert probe. Following the simple diagrams etched on its cover, they could retrieve the record and the provided stylus. What would they make of the sounds of the wind and the rain, the call of a whale, the structure of Bach's Brandenburg Concerto, or the warmth in the human greeting, "Hello from the children of planet Earth"? The strange signal was a message for us, a technical puzzle. But the golden record is a message for eternity, a pure expression of hope and an introduction to who we are. The successful resolution of the signal anomaly is a powerful source of inspiration. It tells a story not of flawless perfection, but of perseverance in the face of imperfection. It demonstrates that even when our creations falter, human ingenuity can find a way to restore them. This is a crucial lesson in an age that often seeks easy answers. The work of deep space exploration is hard, slow, and fraught with challenges. The triumph lies not in avoiding problems, but in solving them with grace and intelligence across vast distances. Voyager 2's brief confusion and subsequent recovery is a perfect parable for the scientific endeavor itself. Ultimately, the meaning of the strange signal is twofold. On a technical level, it was a recoverable error, a flipped bit in an aging computer, now corrected. But on a human level, its meaning is deeper. It was a reminder of our connection to the void, a testament to the longevity of a well-built machine, and a showcase for the incredible skill of the people who guide it. It briefly broke the silence, only to make us appreciate the steady, reliable signal all the more. It was a momentary stammer in a long and eloquent monologue, a monologue that continues today, spoken in a faint whisper from the darkness between the stars. The science instruments on board, such as the cosmic ray subsystem and the plasma science experiment, were built to last 5 years. The fact that they are still returning coherent data after more than 45 years is a near miracle of engineering. They are operating in temperatures far colder than they were ever tested for on Earth, bombarded by radiation they were not fully designed to withstand. Each data point they transmit is a testament to the care and quality put into their construction by a generation of engineers who could not have possibly imagined their creations would one day become our first direct probes of the interstellar medium, forever expanding the boundaries of human knowledge. The ongoing mission of Voyager 2 is a form of temporal communication. We are in dialogue with the past. The engineers of today are using the tools of today to interface with the technology of yesterday, all to explore the universe of tomorrow. The probe itself is a time capsule of 1970s technology, while the team operates in the 21st century. This temporal bridge is essential. The strange signal forced the current team to delve even deeper into the mindset of the original designers, to understand their logic and anticipate their design choices, creating a bond of shared purpose across half a century of human history. The event also highlights the irreplaceable role of our deep space network. Without these colossal sensitive radio antennas in California, Spain, and Australia, Voyager's whisper would be completely inaudible. These facilities are the unsung heroes of planetary science, the vital infrastructure that makes all of our deep space exploration possible. They are our collective ear to the cosmos, listening patiently for the faintest signals from our robotic explorers. The diagnosis and repair of Voyager 2 was as much a testament to the capabilities of the DSN as it was to the ingenuity of the mission team, a perfectly synchronized effort between Earth and space. This brief anomaly provides a moment to reflect on the nature of exploration. It is not a singular event, but a long, sustained effort. The grand flybys of Jupiter, Saturn, Uranus, and Neptune were the spectacular highlights, but the true journey is what happens in the decades between and after. It is the quiet, daily work of monitoring, maintaining, and troubleshooting. The strange signal was a glimpse into this hidden side of exploration, the meticulous, patient, and deeply human process of keeping a dream alive, one command, one bit, one day at a time, as our creation sails ever further into the great unknown. As Voyager 2 recedes, its view of our sun changes. From its current vantage point, the sun is still the brightest star in the sky, but it no longer appears as a disk. It has shrunk to a brilliant point of light, indistinguishable from other stars except for its brightness. This perspective shift is profound. For the probe, home is no longer a grand, central star, but just one of many lights in the galactic tapestry. This is the ultimate journey of exploration, to travel so far that your point of origin loses its special status and becomes just another part of the magnificent whole, a pale blue dot orbiting an ordinary star in a forgotten corner of the galaxy. The power of analogy is useful here. Imagine writing a letter to a friend who lives a world away. You place it in the mail and wait weeks for a reply. Now imagine your friend is on a ship sailing into uncharted waters, and the letter takes 18 months to arrive, with another 18 months for the reply. That is the scale of the patience required by the Voyager team. The strange signal was like receiving a letter back that was water-damaged and illegible. The team had to infer the problem, write a new letter with instructions, and then wait 3 years in our analogy for confirmation. This is a timescale of communication that demands a unique and profound level of dedication. The data Voyager 2 sends back is not just about the interstellar medium. It is also about our own solar system's footprint in the galaxy. The heliosphere, our sun's protective bubble, acts as a shield, deflecting a significant portion of incoming galactic cosmic rays. By comparing the measurements from inside and outside this bubble, scientists can better understand the exact nature of this shielding effect. This has profound implications for understanding the radiation environment that future human explorers might face on long-duration missions to Mars and beyond. Voyager is not just exploring the galaxy, it is helping us understand how to safely explore our own cosmic backyard. The very computer that experienced the glitch, the Flight Data Subsystem, has a memory of about 68 kilobytes. This is less memory than is required to store a single low-resolution icon on a modern smartphone screen. Into that minuscule digital space, the original programmers had to fit the entire operating system, the attitude control software, the instrument command sequences, and the data formatting protocols. The efficiency and elegance of this code is breathtaking. It is a masterwork of digital minimalism. The strange signal arose from a single bit error within this incredibly compact and vital architecture, highlighting just how much complexity and importance was packed into such a tiny computational space. What does it feel like to be Voyager 2? Of course, it is a machine, and does not feel, but if we could anthropomorphize it, we might imagine a growing cold, a fading of the familiar warmth of the sun, and an increasing awareness of a new kind of environment. The solar wind, a constant presence for its entire life, has faded to nothing. Now it feels the faint but persistent breath of the galaxy itself, the true interstellar wind. It is a citizen of two worlds, born of the solar system, but now living its final years as a resident of the Milky Way at large. Its strange signal was a brief confusion about its place, a moment of disorientation at this profound cosmic boundary. The light from our entire galaxy, the Milky Way, takes 100,000 years to cross from one side to the other. In its 45 years of travel, Voyager 2 has covered about 0.002% of 1 light-year. This is a humbling measure of its journey. While it has crossed into interstellar space, it remains, on a galactic scale, infinitesimally close to home. Yet, this tiny first step is arguably one of the most significant achievements of our species. The strange signal and our ability to correct it demonstrates that even across these initial tentative distances, we can maintain a connection. It is a hopeful sign that as our reach expands, our ingenuity will keep pace. In the end, the story of this signal is a story of listening. In our noisy, fast-paced world, the Voyager mission is an exercise in quiet, sustained attention. For decades, a team of people has been listening to a faint, fading voice. They have learned its language, understood its rhythms, and when it faltered, they knew what to do. The signal was not a mysterious alien broadcast, but something far more intimate, a sign of trouble from a trusted old explorer. The answer was not to panic, but to listen more closely, to think more deeply, and to respond with care and precision. It is a lesson in communication that transcends science and engineering. The legacy of this event will be woven into the fabric of the mission's history. It will be a case study for future mission controllers, a textbook example of remote, interstellar troubleshooting. It reinforces the idea that spacecraft are not static objects, but dynamic systems that age and change over time. Managing them requires a kind of coevolution, where the human team adapts its strategies and techniques to meet the changing needs of their distant machine. The strange signal was not a failure, but a learning experience, a new data point in our long education on how to operate at the very edge of possibility. One by one, the systems will be powered down. First, the less critical instruments, then the heaters that protect the sensitive electronics. The gyroscopes used for orientation will be next, leaving the probe to slowly and gracefully tumble through the void. The very last trickle of power will be reserved for the radio transmitter. For a few final months or years, it will send back only a simple carrier tone, a pure, unmodulated signal. This will be its final heartbeat, a steady pulse confirming its existence. Then, sometime around 2030, the power will dip below the required threshold, and the heartbeat will stop. Silence will fall. But the journey will continue. For millions of years, Voyager 2 will sail on, a cold, silent ghost ship. It will outlast its creators, the pyramids, the continents themselves. It is one of the most durable things humanity has ever made. The strange signal was a brief, ephemeral moment in this almost eternal lifespan. It was a problem of the here and now, a challenge for the living. The probe's ultimate destiny lies far beyond these concerns, in a deep future we can barely imagine, carrying its golden record and the memory of the clever, caring species that sent it on its way. Thus, the strange signal from Voyager 2 was not a mystery of the cosmos, but a puzzle of our own making. Its resolution was not a discovery, but an act of recovery. It was a deeply human story of a machine built to explore, of the unforgiving environment it travels through, and of the enduring connection maintained by the intellect and dedication of its caretakers back on Earth. The signal has faded back to its normal, steady rhythm, a familiar whisper once again carrying priceless knowledge from the interstellar dark, a testament to a journey that continues to push the very definition of endurance. Let us now journey deeper into the anatomy of this extraordinary machine, to understand the symphony of systems that must work in concert to make its mission possible. At the core of Voyager 2 is its high-gain antenna, a 3.7-meter parabolic dish that serves as both its mouth and its ears. This is the component that must remain pointed at Earth with unwavering accuracy. Even a slight deviation of a single degree would cause the signal to miss our planet entirely. The successful reset of the AACS was, therefore, an act of preserving this vital line of sight, ensuring that the whisper from the void continues to find its way home to the listening ears of the Deep Space Network, a feat of celestial marksmanship across a gulf of billions of miles. Extending from the main body of the spacecraft is a 13-meter magnetometer boom. This immense, delicate appendage was deployed shortly after launch and serves a critical scientific purpose: to isolate the sensitive magnetometer instruments from the magnetic interference generated by the spacecraft's own electronics. It is on the tip of this boom that Voyager 2 truly tastes the magnetic fields of space. In the solar system, it measured the complex magnetospheres of the giant planets. Now, in the interstellar medium, it measures the faint but powerful magnetic field of the Milky Way itself, providing unprecedented data on the invisible structures that govern our galactic neighborhood. The boom makes Voyager a compass swimming in a cosmic river. The strange signal was a software problem, but the hardware it controls is a marvel of 1970s electromechanical engineering. The AACS steers the probe using a series of tiny thrusters, each producing just a puff of hydrazine gas, about half a pound of force. These thrusters fire in milliseconds-long pulses to make minute adjustments to the spacecraft's orientation. The fact that these valves, seals, and fuel lines have continued to operate flawlessly for nearly half a century in the cryogenic temperatures of deep space is an astonishing testament to their robust design. Each tiny pulse is a carefully calculated action, a minute course correction on an infinite voyage, commanded by a mind on a world the probe can no longer truly see. Another key instrument still in operation is the plasma wave subsystem, which uses two long antennas extended like feelers to measure the waves and oscillations in the plasma of space. This instrument allows scientists to listen to the sound of the space environment. It heard the crackle of lightning in Jupiter's atmosphere, the eerie chorus of waves in Saturn's magnetosphere, and now it hears the gentle hum of the interstellar plasma. In May of 2019, this instrument detected a new rising tone, a clear sign that the density of the interstellar gas was increasing as the probe traveled further. Voyager 2 is not just seeing the new environment, it is hearing it, translating the physics of the void into a language we can comprehend. The team that operates this vintage hardware is a unique blend of generations. It includes veteran engineers who were present during the planetary encounters of the 1980s, their minds a living archive of the mission's history and the spacecraft's idiosyncrasies. It also includes younger engineers and scientists who bring new programming skills and analytical techniques to bear on the ancient data streams. This transfer of knowledge is vital. The strange signal was solved not just by consulting old documents, but by the fusion of old wisdom and new approaches. The mission survives on this human continuity, a multi-generational promise to keep listening until the very last whisper from Voyager has faded into silence. The Voyager interstellar mission, as it is now called, operates on a budget that is a tiny fraction of what is required for a new flagship mission. It is a masterclass in frugal and efficient science. The team is small, the resources are limited, but the scientific return remains immense. Every piece of data is precious because it comes from a place we cannot otherwise reach. The strange signal anomaly, while alarming, was also a moment of intense focus for this team, a convergence of all their collected expertise on a single, critical problem. Its successful resolution is a powerful demonstration that groundbreaking science does not always require the newest, most expensive hardware, but often relies on the sustained, dedicated operation of proven, priceless assets. To understand the challenge the Voyager team faced, consider the nature of its computer memory. It is not solid-state like modern RAM. It is plated wire memory, a technology from the 1960s. It is robust and radiation-hardened, but it is also incredibly slow and small. The engineers cannot simply upload a large software patch as we do with our computers today. Any change to the code must be meticulously planned, broken into tiny packets of information, and uplinked over many hours or even days. The command to reset the AACS memory was likely only a few bytes of information, but the intellectual effort required to ensure those few bytes were exactly correct was monumental. It was the digital equivalent of performing microsurgery from across the solar system. The cosmic rays that likely caused the signal anomaly are a constant, pervasive threat. These particles travel at such high energies that they pass through the hull of the spacecraft as if it were not there. For the most part, they do no harm. But every so often, one will score a direct hit on a sensitive microelectronic component. Modern spacecraft have redundant systems and error-correcting codes to mitigate this, but Voyager's primary defense is its age. Its electronic components are physically larger, meaning a single particle strike is less likely to cause a critical failure. The strange signal was a reminder that this defense is not perfect. The probe is in a constant, silent battle with the universe, and occasionally, the universe scores a hit. The data returned from Voyager 2 has painted a surprising picture of the interstellar boundary. Instead of a smooth, uniform transition, the probe discovered a complex and turbulent frontier. It found that the heliopause, the true edge of the sun's influence, is a surprisingly sharp and distinct boundary, which it crossed in the span of a single day. Just beyond this edge, it detected a magnetic barrier, a region where the galactic magnetic field piles up against our solar bubble, becoming stronger and more compressed. This is knowledge that could not have been gained from afar. It required a direct emissary to pass through the frontier and report back on what it found. The strange signal was a threat to this priceless ongoing report. The longevity of the mission has allowed for a unique kind of science, the study of change over time. As the Sun goes through its 11-year cycle of activity, the heliosphere breathes, expanding and contracting. Voyager 2 is now far enough away that it can measure how these solar weather patterns propagate to the outermost edge of the system and interact with the galactic environment. It is acting as a distant buoy, observing the impact of solar storms and flares as they ripple across the solar system and finally dissipate into interstellar space. This provides a holistic view of our solar system as a single, dynamic entity, a cohesive system interacting with its galactic home. The fact that we can still communicate with Voyager 2 at all is due to a series of upgrades made to the Deep Space Network over the decades. The giant 70-meter antennas have been equipped with more sensitive receivers, more powerful transmitters, and more sophisticated signal processing hardware. We have essentially been building better ears to hear Voyager's fading voice. The recent anomaly was resolved by commands sent from the recently upgraded DSS-43 antenna in Canberra, Australia, the only dish in the world with a transmitter powerful enough and positioned correctly to send commands to Voyager 2 in the southern celestial hemisphere. It is a symbiotic relationship. The spacecraft ages, but its connection to Earth grows stronger through technology. The Voyager probes were born in an era of intense optimism and daring in space exploration, the same era that sent humans to the moon. They represent a certain kind of audacity, a belief that we could build a machine capable of touring the outer solar system and surviving for decades in the unknown. The strange signal and its successful resolution serve as a powerful affirmation of that original audacity. It confirms that the engineers of the 1970s built something not just for their time, but for the ages. We are the inheritors of their magnificent work, and our role now is to be careful and diligent stewards of this incredible legacy as it completes its final, most profound chapter. This entire event was an exercise in trust. The current team had to trust the work and documentation of the original engineers. They had to trust their own analysis of the corrupted data. They had to trust that the 45-year-old hardware would respond correctly to their commands. And they had to trust the laws of physics to carry their message faithfully across the void and bring the response back. This chain of trust, stretching across decades and across billions of miles, is the invisible framework upon which all deep space exploration is built. The return of the clear signal was a moment where that trust was profoundly validated, a confirmation that the chain remains unbroken. As the probe ventures further, the very nature of its measurements changes. Inside the heliosphere, its instruments were primarily measuring particles originating from our own sun, the solar wind. Now, the vast majority of particles it detects are galactic cosmic rays, originating from distant supernovae and other energetic events throughout the Milky Way. It is no longer studying our star's weather. It is studying the weather of the galaxy. This shift in perspective is monumental. It is the equivalent of a mariner leaving a familiar coastal bay and sailing out into the vast, open ocean for the first time, finally able to measure the true character of the global currents. The strange signal from Voyager 2 can be seen as a form of emergent behavior. It wasn't a pre-programmed failure mode. It was an unexpected outcome arising from the complex interaction of aging hardware, decades-old software, and the harsh radiation environment. Solving it required a holistic understanding of the entire system. This is a critical lesson for the future of artificial intelligence and autonomous robotics in space. As our systems become more complex, they will exhibit more of these unpredictable behaviors. The Voyager incident demonstrates the continued need for human oversight and the kind of creative, intuitive problem-solving that can diagnose and correct errors that a system was never designed to anticipate. The eventual, inevitable end of the Voyager mission will be a moment of profound cosmic silence. For the first time since 1977, there will be no active human technology operating in interstellar space. Our senses will be drawn back to the edge of our own solar system. This makes every remaining day of the mission incredibly precious. The strange signal was a fire drill, a practice run for the final farewell. It reminded the team and the world just how much will be lost when that signal finally ceases. It has imbued the remaining years of the mission with a renewed sense of urgency and appreciation for the unique, irreplaceable data that continues to flow back from the darkness. The trajectories of the two Voyager probes are a silent, invisible monument in space. They are precisely known, yet utterly intangible. Their paths trace the history of our first foray into the outer solar system and beyond. The strange signal anomaly was a critical juncture on one of those paths, a moment where the line could have ended but instead was secured and continues onward. Future generations may look at charts of the solar system and see these two thin lines extending out into the void, representing a journey that began long before they were born. And they will know that at this particular point on one of those lines, a problem occurred, and a solution was found. One of the key remaining questions Voyager 2 can help answer is how the interstellar medium interacts with the heliospheres of other stars. By providing a direct measurement of the plasma density and magnetic field strength just outside our own system, it gives astronomers a crucial ground truth data point. They can use this information to refine their models of astrospheres, the bubbles that other stars create around them. This allows them to better understand the environments around distant exoplanets and the conditions that might support life elsewhere in the galaxy. Voyager is not just exploring our frontier, it is providing a key to understanding countless others. The power management on the spacecraft is a delicate balancing act. The mission planners have a detailed model of the RTG's power decay, allowing them to predict its output years in advance. Based on this, they have created a, quote, phased shutdown plan, a timeline for turning off specific instruments and heaters. The recent glitch may force them to revise this timeline, perhaps accelerating the shutdown of other components to provide an extra margin of power for the critical AACS. Every decision is a trade-off, weighing the value of one scientific measurement against the overall longevity of the mission. It is a slow, methodical process of letting go, ensuring the most vital functions survive the longest. Let's contemplate the sheer resilience of information. The command to fix Voyager 2 was a fragile pattern of bits, a whisper of radio waves that traveled for 18 hours. It survived the journey, was correctly interpreted by a 45-year-old computer, and successfully rewrote a single faulty piece of data. The confirmation signal made the same journey in reverse, carrying the pattern of a successful outcome. This exchange demonstrates that information can be both incredibly fragile and remarkably robust. In the cold vacuum of space, a coherent pattern of information can be the most powerful thing in the universe, powerful enough to restore a mind, correct a course, and preserve a connection across an ocean of nothingness. The strange signal has, ironically, made Voyager 2 more famous and more appreciated than it has been in years. It brought the mission back into the public consciousness, reminding a new generation of this incredible story of exploration. News of the anomaly spread across the world, and people waited with bated breath for news of its resolution. For a brief moment, the entire planet was united in hoping for the recovery of this tiny, distant probe. This shared experience highlights the power of space exploration to inspire and unify. The probe is not just a scientific instrument. It is a shared cultural icon, an ambassador for all of humanity on its journey into the great unknown. The success of the Voyager program has directly influenced every outer solar system mission that followed. The Galileo mission to Jupiter, the Cassini mission to Saturn, and the New Horizons mission to Pluto were all designed with the lessons learned from Voyager. From gravity assist techniques to spacecraft autonomy and radiation hardening, Voyager wrote the textbook on how to explore the distant reaches of our solar system. The continued operation of Voyager 2 and the recent troubleshooting success adds a new chapter to that textbook, one about managing an interstellar mission and dealing with the challenges of extreme age and distance. It is still teaching us how to be better explorers. The memory of the spacecraft will long outlive its functionality. The golden record it carries is an analog medium, designed to be playable even after millennia of exposure to the cosmic environment. While the computer's digital memory was the source of the recent fault, the record's inscribed analog memory is far more durable. It is a deliberate choice, reflecting a deep understanding of long-term information preservation. The fleeting correctable digital error of the strange signal stands in stark contrast to the permanent, unchangeable cultural statement etched onto the record's surface, a message designed not for us, but for the ages. What might future human explorers, perhaps traveling to the outer solar system centuries from now, think of Voyager 2? They may look upon its trajectory as a sacred path, the first line drawn by humanity into the interstellar void. They might even one day attempt to retrieve it, to bring this priceless historical artifact back to a museum on Earth or Mars. In this distant future, the story of the strange signal would be a key part of its legend. A tale of how the probe faltered and how its creators, from a billion miles away, reached out with a whisper of pure information and brought it back from the brink, ensuring its journey could continue. The plasma that Voyager 2 now flies through is unimaginably thin, with just a few particles per cc. Yet, over the vast distances of the galaxy, this thin medium adds up. It is the substance from which stars are born and the repository for the material ejected by stars when they die. Voyager is providing us with our first direct, in situ chemical and physical analysis of this substance. It is akin to the first explorers on Earth, taking samples of ocean water to understand its salinity and composition. We are finally dipping our toes in the galactic ocean, and the data, sent back on a signal that almost failed, is our first taste of its true nature. The strange signal was fundamentally a communications problem, a breakdown in the clarity of the message. This makes it a powerful metaphor for our own time. It reminds us of the importance of clear, precise communication and the dangers of corrupted information. The Voyager team solved their problem by going back to the source, by relying on fundamental principles and clear, logical thinking. They did not give in to panic or speculation. They worked the problem methodically. In a world often filled with noise and confusion, the story of Voyager's recovery is a quiet ode to the power of clarity, patience, and a shared, rational purpose. The cosmic rays, measured by Voyager, have traveled for millions of years across the galaxy to reach the probe. Each particle is a messenger from a distant, violent event. By studying their energies and composition, scientists can learn about the life cycle of stars, the physics of supernovae, and the processes that accelerate particles to nearly the speed of light. Voyager 2, having left the protective bubble of the Sun, now acts as a pure, unfiltered detector for these galactic messengers. It is a tiny, remote observatory, witnessing the faint echoes of cosmic cataclysms that occurred when our own distant ancestors were first walking the Earth. As we look to the future, to missions that will travel even further, the story of Voyager 2's strange signal will be a crucial data point. It will inform the design of autonomous fault detection and correction systems. An AI on a future interstellar probe will need to be able to do what the human team did: diagnose an unexpected anomaly, trace it to a root cause in its own memory, and perform a targeted reset, all without human intervention. The 2020 Voyager event was a human-in-the-loop demonstration of a process that future probes will need to perform on their own. We are, in effect, teaching our machines how to survive their own digital frailties. The Voyager mission is ultimately a story of duality. It is a story of incredible complexity and profound simplicity. A story of a machine built by human hands that has traveled far beyond any human. A story of a mission that was designed for 5 years but has lasted for nearly 50. And the strange signal adds another duality, a story of a digital failure and a human triumph. It is in these beautiful contrasts that the true poetry of the mission resides. It reflects our own nature, beings of profound limitations who are nonetheless capable of reaching for the infinite, sending our minds and our machines where our bodies cannot yet follow. The silence that will one day fall over the Voyager signal will not be an ending. The probe will continue its journey, its golden record intact. It will become a purely kinetic object, its story told not by radio waves, but by its ceaseless motion. It will be a testament to a single moment in cosmic history when a species on one small planet developed the technology and the will to send a piece of itself into the galaxy. The strange signal was a test of that will, a challenge to our commitment to that journey. By passing that test, we have ensured that the silent story Voyager tells for the next billion years will be one of resilience. Let us imagine the final transmission. It will not be sudden. The signal will slowly degrade over years as the last watts of power are consumed. The coherent stream of data will give way to a wavering carrier tone, and then, That tone will be intermittently lost in the background noise of the universe. The team on Earth will continue to listen, using advanced processing techniques to try and pull the fading sign of life from the static. But one day, after a scheduled listening session, the lead engineer will look at the screens showing nothing but noise and declare the mission over. A quiet, solemn moment in a control room, marking the end of humanity's longest conversation. The strange signal was a corruption of data, turning meaningful information into nonsense. This highlights the fundamental challenge of science, to extract signal from noise. The universe is filled with noise, random thermal fluctuations, stray radiation, the hiss of the cosmic microwave background. The goal of any scientific instrument is to find the meaningful, non-random patterns within that chaos. For a moment, Voyager 2 became a source of noise rather than a detector of signal. The effort to fix it was a microcosm of the entire scientific enterprise, a determined, intelligent effort to restore clarity and meaning in the face of universal entropy. It is a profound thought that the computers that control Voyager are less powerful than a modern pocket calculator. They have no operating system in the modern sense, just a set of hard-coded routines. Yet, these simple minds have successfully navigated the hazards of 4 planetary systems and the interstellar void. This is a lesson in the power of good enough engineering. The probe was not designed to be perfect or infinitely capable, but to be robust, reliable, and sufficient for its task. The strange signal was a momentary lapse in that sufficiency, a problem that was ultimately solved by appealing to the simple, underlying logic of its design. The Voyager team's successful recovery effort can be seen as an act of remote control archaeology. They were digging into the layers of a 45-year-old digital artifact. The original programmers are mostly retired or have passed away. Their comments in the code and their design documents are the historical texts that the current team must interpret. The strange signal was like finding a corrupted passage in an ancient manuscript. The team had to become scribes and scholars, understanding the original language and context in order to carefully restore the meaning without damaging the rest of the text. It was a beautiful fusion of high technology and historical preservation. The energy of the galactic cosmic rays that Voyager is now measuring is staggering. Some individual particles carry the kinetic energy of a well-thrown baseball, all concentrated into a single atomic nucleus. These are the most energetic particles in the universe, and their origins are still a major puzzle in astrophysics. By sampling them directly, far from the confounding influence of the Sun, Voyager is providing the cleanest data set we have ever had on these incredible messengers. Every spectrum it sends back, on a signal powered by the gentle decay of plutonium, is a clue to solving the mystery of the most violent and energetic processes in our galaxy. The Voyager mission has given us some of the most iconic images in history: the Great Red Spot of Jupiter, the rings of Saturn, the ethereal blue of Neptune. But its current mission is imageless. Its cameras were turned off decades ago to save power. Its exploration now is of a different kind, mapping the invisible forces and the tenuous matter that fill the void. This transition from sight to feeling, from pictures to spectra, is a powerful metaphor for maturing exploration. We begin by mapping what we can see, the coastlines and the continents. But true understanding comes from probing the unseen currents, the deep ocean temperatures, the magnetic fields that shape the world. The strange signal incident was, in a way, a dialogue between the spacecraft and its creators. The probe sent a message of confusion. The team responded with a message of clarification. This is a far cry from the one-way monologue of the Golden Record, which is designed for an unknown recipient. This technical dialogue is active and ongoing. It is a partnership. The machine is our proxy, our sense organ in a distant realm, and we are its consciousness, its memory, and its remote troubleshooting guide. The bond is symbiotic. The probe provides the data. We provide the meaning, the context, and when necessary, the correction. The final state of Voyager 2 will be one of pure Newtonian elegance. Once its power is gone and its systems are inert, it will be subject only to the gravitational pull of the Milky Way galaxy. Its trajectory will be a perfect, silent orbit around the galactic core, a dance choreographed by the collective mass of 100 billion stars. It will become a tiny artificial moon of the galaxy itself. its complex life of exploration and communication will resolve into a simple, beautiful path through space-time, a path that will continue for billions of years, a perpetual monument to the brief moment when its creators looked up and reached for the stars. The very concept of interstellar space was largely theoretical before Voyager. We could observe it from afar, but we had never touched it. Voyager 1 and 2 transformed it from a concept into a place. Their measurements have given it texture, temperature, density, and a magnetic personality. The strange signal was a reminder of the harshness of this new place. It is not a gentle void. It is an active environment filled with radiation and subtle forces. By surviving this glitch, Voyager 2 has proven its mettle as a true interstellar vessel, capable of weathering the real conditions of the galactic environment, not just the imagined ones. The solution to the AACS problem ultimately came down to a single command: a poke to a memory register. This command is a relic from the earliest days of computing. It is a direct, low-level manipulation of a machine's memory. The fact that this primitive tool was the key to saving our most advanced explorer is a beautiful piece of irony. It shows that sometimes, the most sophisticated problems require the simplest, most fundamental solutions. It was not a complex new algorithm that saved Voyager, but a well-aimed, digital tap on the shoulder, a simple reset that reminded the machine of its purpose and its home. In the distant future, the legacy of Voyager may not be its scientific data, which will be superseded by more advanced probes, but the story of its journey. Stories are how we make sense of the universe and our place in it. The story of Voyager is an epic of endurance, of human ingenuity, and of a small, tenacious machine sailing into an infinite ocean. The chapter of the strange signal is a crucial part of that story, a moment of high drama and quiet triumph. It is the part of the story that teaches us that journeys of exploration are never smooth, and that resilience in the face of unexpected trouble is the true measure of the explorer. We must also acknowledge the elegance of the original design. The Voyager spacecraft has multiple, redundant computer systems. The AACS computer, which experienced the glitch, is separate from the main command and control subsystem and the flight data subsystem. This distributed architecture is what made a targeted reset possible. If all functions had been run by a single, monolithic computer, a memory glitch might have been catastrophic, crashing the entire system. This thoughtful, modular design from the 1970s is what gave the 21st century team the tools they needed to isolate the problem and execute a safe, effective repair. The solution was enabled by a choice made 50 years ago. The strange signal was, in the grand scheme of things, a minor event, a temporary data anomaly. But its significance lies in what it represents. It represents the frontier. On any frontier, whether terrestrial or cosmic, explorers face the constant risk of equipment failure far from any hope of easy repair. The Voyager team's success is a modern version of the classic frontier story: the skilled mechanic, the broken-down engine, and the ingenious fix that allows the journey to continue. It reaffirms that the spirit of exploration is not just about where you go, but about how you overcome the obstacles that inevitably arise along the way. The continued health of Voyager 2 is a gift to future scientists. The data it collects is publicly archived, available to any researcher in the world. A graduate student today can download raw data from the edge of the solar system and perhaps make a discovery that the original mission planners never anticipated. The mission's value grows with time as new analytical techniques and new theoretical models are developed that can be tested against this priceless ground truth data. By fixing the probe, the team did not just save a historic mission. They preserved a vital, active scientific resource for a generation of scientists yet to come. The distance to Voyager 2 is a number so large it is difficult to comprehend, over 12 billion miles or 19 billion kilometers. A better way to frame it is in light hours. It is currently over 18 light hours away. This means we are seeing it and hearing from it as it was 18 hours in the past. It is a living time machine. When the strange signal first arrived, the event that caused it had actually happened almost a full day earlier. This temporal disconnect is a fundamental aspect of cosmology and deep space operations. We are always interacting with a ghost of the present, a memory of the immediate past, a condition dictated by the finite speed of light. In a way, Voyager 2 is now exploring two frontiers simultaneously. The first is the physical frontier of interstellar space. The second is the engineering frontier of extreme spacecraft longevity. We have never operated a machine for this long in such a hostile environment. Every day, the probe is teaching us new lessons about how materials degrade, how electronics respond to decades of radiation, and how to manage dwindling power resources. The strange signal was one such lesson. This engineering data is just as valuable as the scientific data, as it will inform the design of future probes meant to last not just for decades, but for centuries. The story of the signal is a reminder that space is not empty. It is a dynamic place filled with energy and matter. The very particle that likely caused the glitch was born in a star that died millions of years ago, and it traveled across the galaxy to randomly intersect with a human-made object just a few meters across. This is a beautiful illustration of the interconnectedness of the cosmos. Our tiny probe is not separate from the galaxy, it is a part of it, subject to its laws and its phenomena. The signal was the result of a direct physical interaction between our local technology and the wider galactic environment, a moment of contact in the truest sense. When we look at the night sky, we see the stars as points of light. Voyager 2 is now traveling through the medium between those points. It is in the space we perceive as empty, and it has found that this space is not empty at all. It is a complex environment, a sea of particles and fields. This fundamentally changes our perception of the night sky. It is not a void with objects in it. It is a continuous substance with varying densities and energies. The strange signal was a brief interruption in our study of this substance, a reminder that the empty space our probe is charting is a challenging and formidable realm in its own right. The resolution of this anomaly gives us hope. It shows that even our most distant and isolated creations are not beyond our help. It proves that with ingenuity, patience, and dedication, we can overcome immense challenges. This sense of hopeful capability is perhaps the most important psychological contribution of the space program. It is a counter-narrative to stories of limitation and decline. The Voyager mission, and particularly this recent chapter, tells us that our reach is long, our minds are powerful, and our ability to solve difficult problems is one of our greatest defining characteristics as a species. The clear signal is a signal of our own competence. So what does the strange signal from Voyager 2 mean? It means that our journey into the cosmos is not a simple, straight line, but a complex, unfolding narrative with moments of peril and grace. It means that our technology is both fallible and remarkably resilient. And it means that the human connection, the bond between creator and creation, can be maintained across unimaginable voids. The signal was a brief question mark in a long statement of discovery, a question that has now been answered not by new data from the probe, but by the quiet, brilliant dedication of the team that continues to guide it home. The strange signal event has subtly altered the very character of the Voyager mission. It has transformed it from a passive process of data collection into an active, ongoing dialogue with the challenges of deep time. The engineers and scientists are no longer just observers. They are custodians, caretakers of an aging but priceless artifact. Each decision to ration power, each command uplink to tweak a subsystem, is an act of preservation. They are not merely operating a spacecraft. They are performing a delicate, long-distance life support procedure for our oldest and most venerable explorer, ensuring its senses can remain open to the wonders of the interstellar medium for as long as physically possible. Consider the psychology of the Voyager team. They work on a timescale that is alien to the modern world. In an era of instant gratification and constant updates, their work is defined by profound patience. They send a command and then go home, work on other projects, and sleep, knowing that the result of their action will not be known until the day after tomorrow. This enforced delay fosters a deep, contemplative approach to problem solving. It is a mindset that values foresight, precision, and a thorough understanding of consequences over speed. The strange signal was a test of this mindset, and the team's calm, methodical response was a masterclass in the forgotten art of slow, careful, deliberate thought. The knowledge required to operate Voyager 2 is a specialized and endangered form of expertise. It exists in a handful of minds and a collection of aging documents. It cannot be learned from a textbook. It must be absorbed through years of direct experience, passed down from one generation of the mission team to the next, like an oral tradition. This human element is the mission's secret to longevity, It is a living repository of knowledge about every quirk and contingency. The successful recovery from the signal anomaly was a victory for this institutional memory, proving that, in the end, the most important component of any spacecraft is the dedicated team of human beings watching over it from home. It is worth pausing to appreciate the sheer audacity of the mission's original goal, the Grand Tour. The alignment of the outer planets that made it possible was a once-in-176-year opportunity. The engineers had one shot to get it right. They had to design a machine that could survive the intense radiation of Jupiter, the cryogenic cold of deep space, and the complex gravitational choreography required to slingshot from one world to the next. That this machine, a product of 1970s technology, not only perfectly executed this celestial ballet, but is still functioning today, is a triumph of a scale that is hard to overstate. The strange signal was a minor stumble in a performance that has been running flawlessly for nearly 5 decades. The strange signal was a reminder that Voyager 2 is an object with a history. It carries the marks of its long journey. Its surfaces are likely pitted by micrometeoroids. Its thermal blankets are frayed and degraded by decades of radiation. Its electronic components have been stressed by countless temperature cycles. It is not the pristine machine that left Cape Canaveral in 1977. It is a veteran, a survivor. Each anomaly, each glitch is a new scar, a new chapter in its long story. Understanding this history is key to diagnosing its present-day problems. The engineers are not just debugging a computer. They are treating the accumulated wear and tear on a seasoned interstellar traveler. The distance to Voyager 2 is now so great that the light from our Sun, which takes 8 minutes to reach Earth, takes over 18 hours to reach the probe. From its perspective, the events we experience are ancient history by the time their light arrives. This temporal gulf creates a sense of profound separation. The probe lives in a different now than we do. This is why its continued connection feels so miraculous. It bridges not just space, but time, creating a tenuous link between two vastly separated frames of reference. The strange signal was a momentary threat to this incredible bridge, a reminder of how easily our connection to that other now could be lost forever. The low-energy charged particle instrument on Voyager 2 is another of its key remaining senses. This device is designed to measure the intensity and direction of the flow of ions in space. Inside the solar system, it was a crucial tool for understanding the solar wind and the trapped radiation belts around planets. Now, in interstellar space, it is tasting the very breath of the galaxy. It can distinguish between particles leaking out from our heliosphere and those that are truly of galactic origin. This provides a direct measure of the porousness of our solar bubble, telling us exactly how much of the galaxy gets in and how much of our Sun gets out. The successful diagnosis of the signal anomaly relied heavily on a technique called telemetry analysis. The engineers on Earth do not have physical access to the probe, so they must deduce its internal state from the stream of data it sends back. This stream contains not just the science data, but a constant health report on thousands of variables: temperatures, voltages, pressures, and system statuses. The strange signal was a corruption in this health report. The team had to act as remote diagnosticians, carefully comparing the garbled data to historical trends and computer models to pinpoint the exact location of the digital disease, a remarkable feat of long-distance forensic engineering. Let us consider the cultural impact of this single, venerable machine. The images it sent back of the outer planets are now embedded in our collective consciousness. They adorn textbooks, documentaries, and museum walls. They transformed abstract points of light into vibrant, complex worlds. This initial mission of discovery has permanently enriched human culture. The current interstellar mission continues this legacy, but in a more subtle way. It is no longer providing images, but something more profound, a sense of our true cosmic context. The strange signal, by momentarily threatening the mission, reminded us of its ongoing cultural value as a symbol of our relentless, enduring curiosity. The Voyager mission is a powerful argument for long-term thinking. It was conceived by one generation, built and launched by another, and is now being operated by a third and even a fourth. Its scientific returns have been spread over 5 decades. In a world that often prioritizes short-term gains, Voyager stands as a testament to the incredible power of sustained, multi-generational projects. The strange signal was a challenge that could only have been met by an organization that had carefully preserved and passed down knowledge over that entire span. It is a model for how we might approach other long-term challenges, from climate change to building a sustainable civilization. The plasma Voyager 2 now traverses is fundamentally different from the plasma of the solar wind. Solar wind plasma is hot and tenuous, with its particles originating from the sun's corona. The interstellar plasma is colder and denser, a vast sea of material composed of the remnants of ancient stars. The probe's crossing of the heliopause was a moment of cosmic immersion, like a river meeting the ocean. The data it sends back allows us to analyze the properties of this ocean for the first time. We are learning its temperature, its density, and its flow, information that is crucial for understanding the environment in which our solar system journeys as it orbits the galactic center. The Cosmic Ray Subsystem, or CRS, is one of the most important instruments for the interstellar mission. This device is essentially a particle telescope, capable of identifying specific atomic nuclei and measuring their energies. Outside the heliosphere, it is no longer shielded from the full intensity of galactic cosmic rays. The data has shown that the energy spectrum of these particles is different than what was predicted by models based on observations from within the solar system. This is a revolutionary finding. It means our sun's magnetic bubble does more than just deflect particles. It actively reshapes the energy distribution of those that get through, a subtle and complex filtering effect we are only now beginning to understand. One of the great mysteries Voyager 2 of May helps solve is the so-called local interstellar cloud, a slightly denser wisp of gas that our solar system is currently passing through. We can observe this cloud remotely from Earth, but Voyager is giving us our first direct sample of its properties. Is it a remnant of a nearby supernova explosion? Is it a piece of a larger galactic structure? By measuring the precise composition and magnetic field of this cloud, the probe is providing the ground truth data needed to answer these questions. The strange signal was a momentary threat to our ability to fully characterize this small, local piece of galactic weather through which we are all, unknowingly, traveling. The magnetometer data from interstellar space has been particularly surprising. Models predicted that the galactic magnetic field would be orderly and aligned with the plane of the galaxy. However, Voyager's measurements show a field that is much more turbulent and dynamic, likely compressed and distorted by its interaction with our heliosphere. This tells us that our solar system does not just passively move through the galaxy, it actively shapes its immediate environment, creating a bow wave and a wake, much like a ship moving through water. Voyager 2 is currently traversing this wake, giving us a unique perspective on the complex physics of this immense, invisible structure. The strange signal was a binary problem, a 0 that became a 1. This tiny, fundamental error highlights the digital nature of modern exploration. The universe is analog. It is a continuum of forces and fields. Our probes translate this analog reality into discrete digital packets of ones and zeros to send it back to us. The process is incredibly powerful but introduces points of fragility. The AACS glitch was a moment where the translation broke down. The solution, a simple digital reset, was a reaffirmation of our control over this process, a successful reimposition of digital order onto a momentary flicker of chaos. The mission's longevity allows for the serendipitous observation of transient cosmic events. For instance, if a nearby star were to go supernova, Voyager 2 would be in a unique position to measure the arrival of the shockwave and the pulse of cosmic rays, completely unshielded by the heliosphere. Such an observation would be a once-in-a-civilization scientific opportunity. While the probability is low, it is not 0. This possibility adds a layer of quiet excitement to the ongoing mission. Each day it continues to operate is another day it stands ready as our silent, distant sentinel, waiting to witness any unexpected drama the galaxy might have in store. The very act of sending commands to Voyager 2 is an expression of hope. The team cannot be certain that the command will be received or that the spacecraft will respond as expected. Each transmission is a carefully calculated risk, an act of faith in the resilience of their creation and the validity of their own analysis. The 36-hour wait for confirmation is a period of suspended judgment, a quiet interval of profound uncertainty. The return of a clear, stable signal after the recent repair was the fulfillment of that hope, a powerful moment of confirmation that their faith was well placed and their analysis was correct. The Voyager probes have fundamentally rewritten our understanding of planetary rings. Before Voyager, we knew only of Saturn's grand system. Voyager 2 discovered the faint, dark rings of Jupiter, the clumpy, incomplete ring arcs of Neptune, and the slender, ethereal rings of Uranus. It revealed that rings are a common, though diverse, feature of giant planets. This discovery alone would have made the mission a resounding success. That it came as just one part of a much grander journey of discovery is a testament to the incredible scientific efficiency of the Grand Tour concept, a mission design that delivered revolutionary science at every single stop along its path. The encounter with Neptune's moon Triton in 1989 was a stunning final act for Voyager 2's planetary mission. It revealed a bizarre and unexpected world, with a surface of frozen nitrogen and active cryovolcanoes erupting plumes of dark material into a razor-thin atmosphere. This was the first time we had witnessed active geology at such extreme cold temperatures. This discovery shattered our preconceived notions of where active worlds could exist, opening up the entire outer solar system as a potential realm for complex geological processes. It was a spectacular grand finale before the probe began its long, quiet journey into the interstellar dark. Every aspect of the Voyager mission has been optimized over time. For example, the way data is encoded for transmission has been updated. The original error correction codes were powerful for their time, but as the signal has weakened with distance, the team has switched to more advanced coding schemes implemented in the software of the Deep Space Network on the ground. This allows them to successfully decode a much fainter signal. It is a perfect example of how the mission co-evolves with technology. The probe itself is frozen in time, but the methods we use to listen to it are constantly improving, extending its useful life far beyond what its original designers thought possible. No discussion of Voyager's legacy is complete without reflecting on the pale blue dot. This image, taken by Voyager 1 at the request of Carl Sagan, shows Earth as a single tiny pixel suspended in a sunbeam. Its philosophical impact has been immense. It is a humbling portrait of our place in the cosmos, a visual representation of our cosmic insignificance and, paradoxically, the preciousness of our world. The strange signal from Voyager 2, its sister probe, serves as an auditory and technical echo of this same idea. The fragility of the signal mirrors the fragility of that pale blue dot, reminding us that our connection to the cosmos, and indeed our existence, is a precious and tenuous thing that requires our constant, careful attention. The Golden Record is Voyager's ultimate legacy, a message for a future we cannot predict. Its contents were chosen by a committee led by Carl Sagan to represent a broad cross-section of humanity. It includes images of our science, our art, our diversity, and our daily lives. It includes the music of Bach, Beethoven, and Blind Willie Johnson. It is an attempt to distill the essence of our world onto a single, durable object. It is a profoundly hopeful artifact. The strange signal was a technical problem for the machine, but the record is a spiritual message from its makers, a statement that even if our machines fail, our music and our ideas will travel on. The success of Voyager has set an incredibly high bar for all subsequent missions. It has become the benchmark against which we measure exploration. When we discuss missions like New Horizons or Juno, the comparison to Voyager is inevitable. It created a paradigm of daring, efficient, multi-target exploration that has inspired mission planners ever since. The recent anomaly and recovery adds a new dimension to this legacy. It sets a new benchmark for mission longevity and remote troubleshooting, providing a powerful, real-world case study that will inform the design and operation of interstellar probes for 100 years to come. This strange signal event provides a fascinating contrast between digital and analog systems. The fault was purely digital, a single bit in a stream of code. The fix was also digital. Yet the probe itself is a profoundly analog machine, powered by the continuous physical decay of plutonium. Its journey is an analog path through continuous space-time. The Golden Record is an analog recording. This interplay is beautiful. The mission is enabled by the precise, fragile world of digital control. But its power source and its ultimate message are rooted in the robust, enduring world of physical reality. The digital glitch was a momentary problem. The analog journey is eternal. The Voyager mission has also taught us a great deal about patience in the search for extraterrestrial intelligence. The 36-hour communication delay with our own probe is a humbling lesson in cosmic timescales. Any potential signal from another civilization would likely travel for centuries or millennia. The process of decoding it could take decades. The Voyager mission, with its slow, methodical pace, is a practical training ground for the kind of long-term thinking that will be required if we are ever to engage in a meaningful, interstellar conversation. The strange signal was a small-scale, personal test of the very patience we will need on a grand, species-wide scale. Future interstellar probes inspired by Voyager's legacy will be vastly more sophisticated. They might be propelled by laser sails, powered by fusion, and controlled by advanced artificial intelligence. They will travel much faster and further. Yet, they will all be descendants of Voyager. They will carry the lessons learned from its design, its discoveries, and its failures. The story of the strange signal will be part of their heritage, a foundational myth about the challenges of interstellar flight. It will be a reminder to their designers that no matter how advanced their technology, the universe will always present new and unexpected challenges, and that resilience must be designed in from the very beginning. The trajectory of Voyager 2 is now entirely passive, dictated by the gravity of the planets it passed decades ago. Its course is set. This is a powerful metaphor for cause and effect over long periods. Actions taken in the 1980s are still determining the probe's location and destiny in the 2020s and beyond. The strange signal was a momentary deviation from its planned state, not its planned path. The successful fix was an intervention that put its internal state back on its own predetermined course of graceful aging. It was an act of restoring the probe to its intended timeline, allowing it to continue flawlessly on its unchangeable cosmic path. The Voyager probes are, in a sense, humanity's first ruins. Like the ancient pyramids or temples on Earth, they are monuments to the aspirations of a particular culture at a particular time. But unlike terrestrial ruins, they are not decaying in place. They are actively moving away from us. They are ruins in motion. The strange signal was a brief sign of that decay, a crack in the monument. But the repair was an act of remote restoration, a demonstration that even as our monuments leave us, we can still care for them, preserving their integrity as they drift into the deep future, carrying the story of their makers with them. The science from Voyager has consistently revealed a universe that is more complex and surprising than we had imagined. It found volcanoes on Io, a subsurface ocean on Europa, and the strange cantaloupe terrain of Triton. It has shown that the boundary of our solar system is not a simple bubble, but a turbulent, frothy frontier. This is the great gift of exploration. It replaces our simple models with the messy, beautiful complexity of reality. The strange signal itself was a part of this process, replacing a simple model of a perfectly functioning machine, with the more complex reality of an aging system gracefully coping with the stresses of its environment. As we conclude this reflection on Voyager's legacy, we are left with a sense of profound connection. We are connected to the team that nurtures the mission, to the engineers who built the probe, and to the scientists who first dreamed of the grand tour. Through the spacecraft, we are connected to the outer planets it revealed to us, and now we are connected, however tenuously, to the interstellar medium itself. The strange signal did not break this chain of connection, it strengthened it. It forced us to reaffirm our commitment, to reach out across the darkness, and in so doing, to remind ourselves of the incredible, improbable journey we are all on together. Let us now project our thoughts into the deep future, long after the final signal from Voyager 2 has been lost. For thousands, then millions of years, the probe will drift in the silent, star-strewn darkness of the Orion arm of our galaxy. Its nuclear power source will be long dead, its electronics frozen solid. It will be a ghost ship, a relic of a long-forgotten age of early spaceflight. It will be indistinguishable from a small asteroid to any distant observer, yet it will carry within it the most concentrated package of intelligent information in its region of space. The golden record, a silent promise of a story waiting to be told. The probability of Voyager 2 ever being found by another intelligence is infinitesimally small. Space is simply too vast and the probe is too tiny. But that is not the point. The act of sending the message is what matters. It is a reflection of our own character as a species. It demonstrates that we are not just concerned with the here and now, but that we have a sense of cosmic history and a desire to communicate our existence to the future. The golden record is less a practical attempt at communication and more a philosophical statement, a monument to our own capacity for hope and our desire to be remembered. Over geological timescales, the stars themselves will move. The constellations we see today will distort and change. The probe's trajectory, which is aimed toward the current position of the star Ross 248, will see it arrive in that region of space 40,000 years from now, only to find the star has moved on. Its journey is not toward a destination, but simply through a region. Its fate is to wander. It will become a true interstellar citizen, an object belonging not to a solar system but to the galaxy itself, its path gently shaped by the gravitational tides of passing stars and nebulae over millions of years, a silent dance on a cosmic scale. If, against all odds, the probe is one day intercepted, the diagrams on its cover are the key. They are a scientific Rosetta Stone, providing the information needed to understand the record. They show the location of our Sun relative to 14 pulsars, whose precise rotational periods act as a celestial clock, allowing the finders to calculate when and where the probe was launched. They provide instructions on how to play the record using the included cartridge and needle. It is a masterpiece of minimalist instruction, an attempt to communicate fundamental scientific concepts without any shared language, a pure appeal to universal logic. The materials chosen for the probe and the record were selected for longevity. The main structure is aluminum, the antenna is graphite epoxy, and the record itself is gold-plated copper. In the cold, empty vacuum of interstellar space, there is no oxygen to cause corrosion and very little to erode them. They will last for 1 billion years or more, far longer than any structure on Earth. The probe will likely still be physically intact when the Sun begins to die and expand into a red giant. It is a time capsule not just of our culture, but of our engineering, a durable testament to our ability to build things that can outlast even our own planet's habitable lifespan. The strange signal was a transient event, a problem of the probe's lifetime. But the probe's ultimate journey is on a time scale that dwarfs lifetimes. It will orbit the center of the Milky Way galaxy roughly every 225 million years, completing a galactic year. It will see our solar system's neighborhood change dramatically. New stars will be born in nearby nebulae, and old stars will die. It will be a silent witness to the grand, slow cycles of galactic evolution. It carries the memory of a single brief moment of intelligent life on Earth through ages of cosmic change, a persistent flicker of memory in a vast, evolving universe. The silence of Voyager's deep future is a powerful concept. For its entire operational life, it has been in constant, albeit delayed, communication with Earth. It has been a creature of sound, of radio waves. Its end of mission will be a transition into a state of profound silence. It will no longer speak, and it will no longer listen. Its existence will be defined solely by its physical presence and the information encoded on its surfaces. This transition from an active explorer to a passive artifact is its final, most enduring transformation, a shift from doing to simply being, a final surrender to the quiet, physical laws of the cosmos. Could humanity ever catch up to it? It is a tantalizing thought. Perhaps in a few centuries we will develop propulsion systems that could make the journey in a fraction of the time. A mission could be launched to retrieve Voyager 2, our very own ancient alien artifact. It would be an archaeological expedition of the highest order. Scientists would study the effects of half a millennium of exposure to the interstellar environment on its materials. Historians would marvel at its primitive, elegant technology. It would be a direct, physical link back to the pioneers of the space age, a tangible piece of our own origin story recovered from the void. The final meaning of Voyager's journey may be for ourselves. The probe is a mirror. In its journey we see our own curiosity. In its resilience we see our own ingenuity. In its golden record we see our hopes and our art. In its lonely, infinite voyage we see a reflection of our own cosmic isolation and our desire to transcend it. The strange signal did not change the reflection in the mirror, but it did make us look at it again. It drew our attention back to this distant extension of ourselves, and forced us to contemplate, once more, what it means to be a species that builds such mirrors and sends them out into the dark. The ultimate fate of Voyager 2 is to become one with the galaxy. It will eventually be destroyed, perhaps by a collision with a dust particle at high velocity, or by being pulled into a star or a black hole millions of years from now. Or it may simply continue to orbit for billions of years until the galaxy itself changes beyond recognition. Its atoms, forged in the heart of our solar system, will be scattered and recycled in the endless cosmic dance. It is a beautiful and fitting end. The machine that was sent to explore the galaxy will, in the fullness of time, become a seamless part of it, its journey complete, its purpose fulfilled. And so we return from the deep future to the present moment, to the quiet hum of the control room where the signal from Voyager 2 is being tracked. The strange signal is now a memory, a closed chapter in the logbook, but the lessons from it remain. It taught us that the mission is a living thing, requiring constant care. It reminded us that the universe is not benign and that survival is an active, ongoing struggle. Most importantly, it reinforced the value of the data that continues to stream in. Every bit is more precious now, knowing how close we came to losing it all. The signal is clearer now, both technically and in its profound meaning for us. The strange signal was, at its heart, a question. It was the universe asking our technology, "Are you robust enough to survive out here?" And it was the technology asking its creators, "Are you clever enough to fix me from so far away?" The answer to both questions, for now, is a resounding yes. This successful exchange is a source of quiet confidence. It validates our designs and our operational philosophies. It gives us the courage to plan even more ambitious missions for the future, knowing that we have the capability not just to launch great ventures, but to sustain them through the inevitable challenges that the cosmos will throw in their path. The focus of the mission team now is on the final phase, the graceful decline. They are acting as cosmic hospice caregivers, ensuring the probe's final years are as scientifically productive as possible. They are managing its pain, its dwindling power, and making it comfortable by shutting down non-essential systems. The goal is no longer to add new capabilities, but to preserve the core functions for as long as possible. The strange signal was a health scare that has informed this final care plan, making the team even more cautious and even more appreciative of the time they have left with their distant patient. This entire event has served to recalibrate our sense of awe. The initial awe of the Voyager mission came from the spectacular images of planets and moons. The new awe comes from a deeper, more intellectual place. It is the awe of appreciating the complexity of the interstellar environment. It is the awe of understanding the incredible engineering challenges of longevity. And it is the awe of witnessing the quiet, persistent brilliance of the human minds that keep the mission alive. The strange signal was the catalyst for this shift, moving our sense of wonder from the destination to the journey itself. What Voyager 2 is doing now is pure exploration in its most undiluted form. There are no predetermined destinations, no flyby targets on a calendar. The probe is simply moving through an unknown territory, and its mission is to report on the nature of that territory, whatever it may be. It is a ship on an open ocean, with no land in sight, its crew taking constant readings of the water's depth and the wind's direction. The strange signal was a storm that threatened to damage the ship's compass, but the crew proved capable of making the repairs, and the ship sails on, its logbook still open, its journey into the unknown still underway. The information flowing back from Voyager 2 is now part of the permanent heritage of humanity. It is stored in deep archives, replicated in data centers around the world. It will be studied for generations. The brief period when that data stream was corrupted by the strange signal will be a footnote in that archive, a small anomaly in a vast and priceless dataset. But it is a vital footnote. It tells the story of the data's fragility, of the immense effort required to collect it, and of the successful struggle to preserve its integrity. It is a reminder to all future scientists that data is not just a given, it is a hard-won prize. The mission continues. every day adding another 735,000 miles to its distance from home. The signal gets fainter, the power gets weaker, and the challenges get greater. But for now, the connection holds. The strange signal was a stress test that the entire system, the spacecraft, the deep space network, and the human team, passed with flying colors. It was a demonstration of the remarkable robustness of this half-century-old enterprise. It gives us confidence that the mission can continue for several more years, pushing ever deeper into the galaxy, carrying all of us with it on its silent, historic, and now thoroughly validated voyage. Let us end this chapter where we began, with a signal. But now it is not a strange signal. It is the familiar, steady pulse of data that we have come to rely on. It is a whisper that has traveled for 18 hours, carrying news from the frontier. It speaks of the density of plasma, the energy of cosmic rays, and the strength of the galactic magnetic field. It is the voice of our most distant emissary, a voice that momentarily faltered, but has now returned, clear and strong. It is a voice that speaks of the vastness of the cosmos, but also of the remarkable reach of human ingenuity. The strange signal was a puzzle, and in solving it, we reaffirmed a fundamental truth of exploration, that the universe is full of puzzles, and we are, at our core, a puzzle-solving species. We delight in the unknown, we are challenged by complexity, and we find our deepest meaning in the quest for understanding. The Voyager mission is perhaps the purest expression of this innate drive. The brief anomaly was not a setback, but an opportunity to practice our skills, to prove our capabilities, and to engage once more in the great and ongoing game of solving the universe's riddles. So what did the strange signal from Voyager 2 ultimately mean? It meant that the journey is not over. It meant that the bond between creator and creation remains strong. It meant that even in the face of decay and distance, human ingenuity can find a way. It was a momentary whisper of chaos, answered by a steady voice of reason. It was a test of our resolve, a test we have passed. And now the probe continues its silent passage, its systems stable, its antenna locked on home, dutifully continuing its historic mission to read the faint, subtle, and magnificent story of the space between the stars. The strange signal, now resolved into the annals of mission history, has fundamentally enriched the Voyager narrative. It added a layer of human drama and technical suspense that transcends the cold data of scientific discovery. It reminds us that exploration is not a sterile, predictable process. It is a living, breathing endeavor, filled with moments of uncertainty and triumph. This event has become a key part of the spacecraft's identity, a testament to its resilience, and a symbol of the profound, problem-solving partnership that exists between the distant probe and its dedicated team on Earth. It has transformed the mission from a simple trajectory into a compelling odyssey, with this chapter serving as one of its most gripping moments of challenge and resolution. Reflecting on the AACS glitch, we gain a deeper appreciation for the concept of orientation in the cosmos. For the spacecraft, physical orientation is everything. It is the difference between communication and eternal silence. For us, as a species, psychological orientation is just as critical. We seek to understand our place in the universe, to know where we came from and where we are going. The Voyager mission is a primary tool in this quest for orientation. By mapping the outer solar system and now the interstellar medium, it provides the data points we need to build our cosmic map. The strange signal was a momentary loss of orientation for the probe, which in turn sharpens our own focus on this greater existential quest for our place among the stars. The successful recovery from 12 billion miles away serves as a powerful antidote to cynicism. In a world where it is easy to focus on limitations and failures, the Voyager story is a beacon of human competence. It is a tangible demonstration that we can conceive of audacious goals, build magnificent machines to achieve them, and sustain those efforts over entire human lifetimes. The strange signal was a test of this competence. The outcome, a successful long-distance repair of a 45-year-old computer, is a profoundly optimistic statement. It suggests that with focus, dedication, and intelligence, even the most daunting challenges, across the most impossible distances, are not beyond our ability to solve. The event also casts a new light on the nature of robotic explorers. We often think of them as mere tools, extensions of our will. But a mission, as long as Voyager's, imbues the probe with a character, a personality defined by its history of survival. It is no longer just a collection of circuits and sensors. It is Voyager 2, the veteran, the survivor of Jupiter's radiation, the only visitor to Uranus and Neptune. The strange signal was a sign of its aging, a vulnerability that makes its story more relatable and more compelling. It ceased to be just a tool, and became a protagonist in its own right, its struggle for survival, becoming a drama that we on Earth were privileged to witness and assist. The physics of the interstellar medium, which Voyager 2 is now exploring, is a realm of subtle but powerful forces. The tenuous gas, the sweeping magnetic fields, and the constant rain of cosmic rays create an environment that is radically different from the one inside our solar system. The probe's continued operation provides a stream of data that is a form of weather report from this alien ocean. The strange signal was, in effect, a consequence of this weather, a single energetic particle causing a malfunction. This serves as a potent reminder that as we push further into the galaxy, we will not be traveling through a void, but through a complex and active environment that we must learn to understand and navigate. The story of the strange signal is also a story about information theory. The fundamental challenge of the mission is maintaining signal against the relentless noise of the cosmos. The inverse square law dictates that the signal will always grow weaker, while the background noise remains constant. The brief period of corrupted telemetry was a moment when the signal itself became noise. The recovery was an act of restoring the information content, of pulling a clear message out of the chaos. This is a microcosm of the grander human project of science and art, the effort to create and preserve meaningful patterns of information against the universal tide of entropy and decay. It is fascinating to consider that the technology used to diagnose and fix Voyager 2 is incomparably more advanced than the technology on the probe itself. The mission team uses powerful modern computers, sophisticated data visualization software, and a global network of upgraded radio telescopes to communicate with a machine whose total computing power is less than a digital watch. This technological asymmetry is what keeps the mission alive. We are using our 21st century minds and tools to extend the life of a 20th century marvel. The strange signal was a vintage problem that required a modern solution, a beautiful collaboration across 50 years of technological evolution. The public fascination with the strange signal event reveals a deep-seated human connection to our robotic explorers. We see them as our emissaries, our representatives in the great void. Their triumphs feel like our triumphs, and their struggles elicit our concern and empathy. The global sigh of relief that greeted the news of Voyager's recovery was genuine. It came from a place of shared investment in this grand journey. The probe is not just NASA's, it is a piece of all of us, sailing in the dark. The signal anomaly momentarily reminded us of this shared ownership and our collective hope for its continued, incredible voyage. The very nature of the signal has evolved over the mission's lifetime. In the beginning, it was a fire hose of data, delivering stunning, high-resolution images of new worlds. Today, it is a delicate trickle of numbers, measuring the subtle fluctuations of particles and fields. The value has shifted from the spectacular to the fundamental. It is no longer about seeing new things, but about understanding the very fabric of the space between things. This strange signal was a threat to this more mature, more profound phase of the mission, a phase where every single data point is a hard-won insight into the true nature of our galactic home. The resolution of the signal glitch is a testament to the power of a multidisciplinary team. It required radio astronomers, software engineers, navigation specialists, and physicists, all working together. The problem was not confined to a single domain. It was a complex interplay of radiation physics, computer science, and celestial mechanics. This collaborative approach is the hallmark of modern science. The era of the lone genius is largely over. Great achievements, like saving a distant spacecraft, are the product of a community of experts, each bringing their unique skills to bear on a shared challenge. The clear signal now returning from Voyager 2 is the sound of their collective success. Let us contemplate the quality of silence. For most of its journey, Voyager 2 travels through a profound physical silence, a near-perfect vacuum, where sound cannot propagate. Yet it is a source of a constant radio sound. The strange signal was a moment of dissonance in that sound, a jarring note and a long, clear melody. Its restoration was a return to harmony. This makes us appreciate the immense information content of the normal, boring signal. Its steady, predictable nature is a sign that all is well, that a complex piece of human technology is successfully navigating a hostile environment. The brief flirtation with chaos makes us appreciate the profound beauty of sustained, predictable order. The strange signal event forces us to confront the concept of cosmic timescales. The probe's 45-year journey feels immense to us, spanning multiple human generations. But on a galactic timescale, it is less than the blink of an eye. The particle that caused the glitch may have been traveling for millions of years. The probe itself may travel for 1 billion more. This perspective is humbling. Our most enduring creations are fleeting footnotes in the grand history of the cosmos. Yet this does not diminish their importance. In fact, it enhances it. The fact that we, in our brief moment of existence, can create something that touches these deeper timescales is perhaps our most remarkable achievement. The story of Voyager is a story of leaving home. It has left its home planet, its home star, and the protective bubble of the heliosphere. It is, in a sense, an orphan of the solar system, now making its way in the wider galactic neighborhood. Its only remaining link to that home is the faint radio signal. The strange signal was a threat to this final tenuous tether. Its restoration was an act of reaffirming that connection, a statement that even our most distant children are not forgotten. It is a powerful allegory for any journey of exploration, which is always a balance between the drive to push into the unknown and the need to maintain a connection to the world left behind. In the digital age, we are accustomed to the idea that information is ephemeral and easily replaced. The Voyager mission challenges this notion. The information it sends back is unique and irreplaceable. There is no other sensor in interstellar space. If the data is lost, it is lost forever. This gives every transmission a profound weight. The strange signal was a moment where we faced the reality of that irreplaceability. It wasn't just a computer glitch. It was the potential permanent loss of a unique window on the universe. Its recovery was not just a fix, it was the preservation of a priceless archive, a unique stream of knowledge from a place we may not visit again for a very long time. The very existence of Voyager 2 is a form of time travel. The light from distant stars takes years to reach us, so when we look at the night sky, we are looking into the past. Voyager gives us a different kind of time travel. It sends us a message from its present, but because of the immense distance, that present is 18 hours in our past by the time we receive it. And the probe itself is a relic of our own past, a piece of 1970s technology still operating today. It is a complex tapestry of temporal connections. The strange signal was a knot in that tapestry, a momentary disruption that, once untangled, revealed the incredible strength and intricacy of the threads that connect us to our past and our future. The strange signal was an entirely natural event, likely caused by a single, random cosmic ray. There was nothing supernatural or alien about it. And yet, its resolution felt almost magical. The ability of the human mind to comprehend a problem across such a vast distance, to craft a precise solution, and to restore a complex machine to functionality, is a form of magic in its own right. It is the magic of reason, of science, and of engineering. It is a reminder that the most wondrous things in the universe are not necessarily the mysterious ones, but often the ones we can come to understand through logic, patience, and a relentless desire to know. We are a species of tool builders, and Voyager 2 is one of our finest tools. Like a finely crafted lens or a perfectly balanced hammer, it is an extension of our own capabilities. The strange signal was a moment where the tool faltered. The repair was an act of a master craftsperson tending to their instrument. This relationship between the user and the tool is ancient and profound. The Voyager story elevates this relationship to a cosmic scale. It demonstrates that the bond between creator and creation, the intimate knowledge of a tool's function and its frailties, is a principle that holds true even when the tool is 1 billion miles from the hand that built it. The solution to the Voyager problem was not found in a sudden flash of insight, but through a slow, methodical process of elimination. The team analyzed the data, formed hypotheses, tested them with commands, and analyzed the results. It was a perfect execution of the scientific method. This process is the engine of all human progress. The strange signal provided a perfect, high-stakes case study. It demonstrates that even the most complex and distant problems can be solved by this simple, powerful approach. Observe, hypothesize, test, and conclude. The clear signal now being received is a testament to the enduring power of this rational, structured way of thinking. The journey of Voyager 2 can be seen as a long, slow process of translation. The probe encounters the physical reality of space, the plasma, the fields, the particles. Its instruments translate this reality into electrical signals. Its computer translates those signals into digital data. Its transmitter translates that data into radio waves. The Deep Space Network translates those waves back into data. And finally, scientists translate that data into knowledge, into graphs, papers, and understanding. The strange signal was a glitch in this long chain of translation. Its repair was an act of restoring the integrity of the entire process, ensuring that the story the universe is telling can continue to be heard and understood. There is a certain quiet heroism in the work of the Voyager team. Their names are not famous, and their work is done far from the public eye. They are the silent guardians of our most distant outpost. Their victory over the strange signal was not met with parades or headlines, but with quiet satisfaction in a job well done. This is the true face of exploration. It is not always about daring adventurers. More often, it is about the patient, meticulous, and often anonymous work of the engineers and scientists who make the adventures possible. This steady signal from Voyager 2 is their quiet, constant, and well-deserved reward. The strange signal event has added a new layer to the educational power of the Voyager mission. It is no longer just a story about planetary science. It is now a powerful lesson in engineering, problem-solving, and computer science. Teachers can use this event to explain concepts like binary code, cosmic rays, fault tolerance, and remote operations. It is a real-world example of STEM principles in action at the highest possible level. It shows that science and engineering are not just abstract subjects, but vital, active disciplines that can be used to solve incredible challenges and extend the reach of human curiosity to the very edge of the solar system and beyond. The Voyager 2 spacecraft is now a cultural object. It has transcended its original purpose as a scientific instrument and has become a symbol. It symbolizes the ambition of the Apollo era, the power of human ingenuity, and our unyielding desire to explore. The story of the strange signal has only enhanced this symbolic power. It adds a new theme to the narrative: resilience. It shows that our creations, like us, can face adversity, falter, and then, with care and intelligence, recover. The probe is now not just a symbol of ambition, but a powerful symbol of endurance against the inevitable challenges of a long and difficult journey. The constant stream of data from Voyager, however faint, is a continuous thread connecting us to the cosmos. The strange signal was a moment when that thread frayed and threatened to snap. The successful repair was an act of reweaving that thread, making it strong again. This continuous connection, this unbroken stream of knowledge, is what transforms space from a distant, abstract concept into a tangible environment that we can study and begin to understand. As long as that signal continues, the interstellar medium is not some far-off place. It is a place where we have a presence, a tiny robotic extension of our own senses, reporting back on the wonders it is experiencing. Thinking about the strange signal leads to a deeper appreciation for backup systems and redundancy, which are key principles of good engineering. While Voyager's computers are simple, it does have redundant hardware, including backup thrusters and radio receivers. The team's ability to fix the software glitch relied on the fact that the underlying hardware was still sound. This is a crucial lesson for all complex systems. Things will fail. The key to longevity is to anticipate failure and to build systems that are resilient, with multiple pathways to success. The Voyager mission is a 45-year-long masterclass in the life-saving power of a well-thought-out Plan B. The faintness of the Voyager signal is a direct consequence of the immense scale of the universe. The energy of the signal spreads out over a sphere that is now 18 light-hours in radius, and we on Earth are just a tiny target in that vast area. The fact that we can even detect it is a triumph. The strange signal was a flaw in the content of the message, not its transmission. It reminds us that there are two challenges in interstellar communication: the physical challenge of getting a signal across the distance, and the intellectual challenge of ensuring the signal is coherent and meaningful. We have largely solved the first. The glitch was a brief, powerful reminder of the importance of the second. The Voyager story is a powerful counterpoint to the idea that technology makes us disconnected. In this case, technology is the sole source of a profound connection across an unimaginable distance. The entire relationship between the mission team and the spacecraft is mediated by technology, by radio waves, by computers, by software. It is a demonstration that technology can be a bridge, not a barrier. It can be used to extend our senses, our minds, and our very presence into realms we could never otherwise touch. The strange signal and its repair were a conversation held entirely through the medium of technology, a conversation that reaffirmed our bond with our most distant creation. The strange signal was a random event. A cosmic ray's path is unpredictable. This highlights the role of chance and probability in the universe. Our exploration of space is not a perfectly choreographed dance. It is an improvisation in a dynamic and often chaotic environment. We can plan, we can design, we can anticipate, but we can never eliminate the element of chance. The key to success is not to avoid randomness, but to build systems that are robust enough to recover from it. The Voyager recovery was a triumph of deterministic engineering over probabilistic chaos, a successful effort to impose order on a system that had been briefly touched by the randomness of the cosmos. Ultimately, the story of the strange signal is a story of light. The problem was likely caused by a particle of light, a high-energy photon or cosmic ray. The solution was sent on a wave of light, a radio transmission, and the confirmation of the fix came back to us on another beam of light. The entire event was a drama played out at the universe's ultimate speed limit. It is a beautiful and poetic symmetry. It reminds us that our entire understanding of the cosmos, from the light of distant galaxies to the radio whispers of our own probes, is carried to us on this fundamental medium. We are creatures who have learned to read the universe's light, and even to write back. As Voyager 2 continues its journey, it is slowly, patiently, mapping the contours of our home. Not our home planet, but our larger home, the local interstellar environment. Just as early cartographers mapped the continents of Earth, Voyager is charting the magnetic fields and plasma flows of our corner of the galaxy. It is creating the first true map of the space just outside our door. The strange signal was a moment when the cartographer's pen faltered. Now that it has been restored, the painstaking process of mapping this vast, unknown territory can continue, providing the context for our solar system's place in the grand geography of the Milky Way. The resonance of the Voyager story comes from its fusion of the epic and the intimate. The scale is epic: billions of miles, decades of time, the exploration of entire worlds. But the story of the strange signal is intimate. It is the story of a small team of dedicated people, using their human-scale intelligence to solve a problem with a single beloved machine. This combination is what makes the story so powerful. It connects the grand, cosmic narrative to the relatable, human experience of facing a challenge and finding a clever way to overcome it. It is an epic poem written in the quiet, precise language of engineering. And what of the future? For several more years, the fragile signal will continue to arrive, each day fainter than the last. The scientific mission will end when the last instrument is powered down, a quiet, pre-planned event. Then, for a short while longer, the transmitter may send only a carrier wave, a pure tone, the spacecraft's final, fading heartbeat. And then, one day, a scheduled listening session will hear nothing but the background hiss of the galaxy. In that moment, a great silence will descend. The operational history of humanity's longest and most distant mission will come to a close, ending not with a bang, but with a final, inevitable whisper fading into nothing. But the end of the signal is not the end of the story. It is merely the end of a chapter. The spacecraft will sail on, inert and silent, for a span of time that beggars the imagination. It will outlive its creators, their nations, their languages, and perhaps their species. It will become a silent ambassador to a future we cannot conceive. The strange signal, and the story of its repair, is a part of the legacy that this ambassador carries. It is a story embedded not in the golden record, but in the operational history of the probe itself. A testament to the fact that the people who built it also cared for it, nurturing it through its moment of crisis. The ultimate legacy of Voyager 2 is the perspective it provides. By traveling so far away, it allows us to see our own world in a new light. It has shown us the magnificent worlds of our outer solar system, providing a context for our own planet. It has shown us the vast, empty-seeming space between the stars, highlighting the preciousness of our own small, sheltered oasis. And in its recent technical drama, it has shown us the power of our own ingenuity and the depth of our connection to the things we create. It is a mirror held up to ourselves from the edge of the solar system, and the reflection it shows is one of a curious, clever, and remarkably resilient species. The strange signal was a brief flicker in the long, steady light of the Voyager mission. It was a momentary question in a decades-long declaration of discovery. The question has been answered, the flicker has stabilized, and the declaration continues. The mission has absorbed this event and become stronger for it, its story richer, and its legend more profound. It has demonstrated a resilience that gives us hope, not just for the future of space exploration, but for our own ability to face the unknown, to solve the difficult puzzles, and to maintain our connections, our purpose, and our sense of wonder, as we journey together into the immense and beautiful mystery of the cosmos. The journey of Voyager 2 is now our journey. It carries our music, our languages, our science, and our hope. Its continued survival is a small but potent symbol of our own. The strange signal was a moment of shared vulnerability, a reminder that even our most advanced creations are fragile. Its recovery was a moment of shared triumph, a testament to our ability to care and to correct. As it sails onward, it is no longer just a machine. It is an idea. It is the idea that a species confined to one small planet can nonetheless touch the stars, and that the whispers it sends back can tell us as much about ourselves as they do about the universe. This entire saga, from the initial garbled data to the final, clear telemetry, is a perfect metaphor for the process of understanding itself. We begin with confusion, with a strange signal from the world that does not make sense. We apply reason, patience, and experimentation. We test our ideas against reality, and slowly, methodically, we transform the noise into a clear signal. We turn mystery into knowledge. The story of Voyager 2's strange signal is the story of all science, all art, and all philosophy, played out on a stage of incomparable grandeur, a beautiful demonstration of the human drive to make sense of the magnificent universe we inhabit. Let us appreciate the sheer elegance of the final solution. It was not a brute force fix. It was a delicate, precise, and minimalist intervention. It was the smallest possible action that would have the desired effect. This is the hallmark of true mastery. In science, in art, in engineering, the most elegant solutions are often the simplest. The Voyager team, faced with a monumental challenge, did not respond with a monumental command. They responded with a tiny, perfectly aimed piece of code. It was a whisper of an answer to a whisper of a problem, a moment of profound intellectual grace across a void of 12 billion miles. The strange signal has now been fully integrated into our understanding. It is no longer strange. It is a known event with a known cause and a known solution. This is the fate of all mysteries that yield to scientific inquiry. They cease to be mysterious and become part of the known world. But in their place, new mysteries arise. What other subtle effects of the interstellar medium will Voyager 2 discover? What new challenges will its aging systems present? The end of one puzzle is always the beginning of another. The journey of discovery is infinite. The strange signal was just one step on a path that has no end. The Voyager mission has changed the very questions we ask. Before 1977, we asked, what do the outer planets look like? Now we ask, what is the structure of the interstellar magnetic field? The mission has not just provided answers. It has elevated the quality of our questions. It has pushed the frontier of our ignorance further out into the cosmos. The strange signal and its resolution contribute to this, teaching us to ask better questions about spacecraft longevity and interstellar operations. This is the true measure of a great mission, not just the knowledge it generates, but the new and more profound questions it inspires us to ask. In this cosmic theater, Voyager 2 is a solitary actor on a vast and silent stage. For a brief moment during the strange signal event, the drama was focused entirely on this single actor's struggle. Now, the crisis has passed, and the actor continues its slow, majestic monologue, spoken in the language of data. The audience, us on Earth, continues to listen with rapt attention. The performance is nearing its end, but its power is undiminished. It is a story of endurance, of solitude, and of a message sent from an immense distance, a message that continues to captivate and inspire all who have the patience to listen. The final legacy of the strange signal is one of reassurance. It reassures us that our reach is not limited by distance. It reassures us that our intellect is a powerful tool against the universe's entropy. It reassures us that our commitment to knowledge can be sustained across generations. And it reassures us that our connection to our creations, no matter how distant, can be maintained. It was a momentary scare that has left in its wake a deeper and more profound sense of our own capabilities. The clear, steady signal we receive today is not just data. It is a constant, quiet message of reassurance from the edge of the interstellar dark. The entire Voyager saga is a testament to the human capacity for foresight. The mission was planned by people who knew they might not live to see its ultimate conclusion. They were building a legacy, planting a tree whose shade they would not enjoy. We are now living in that shade, benefiting from their vision and their meticulous work. The strange signal was a challenge to our stewardship of that legacy. In successfully resolving it, we have honored the foresight of the mission's pioneers and have done our part to ensure that this incredible gift continues to give to the generations that will follow us. The story of Voyager 2 is written in radio waves, a script stretching across billions of miles. The strange signal was a single garbled word in that script. The repair was a careful editorial correction. Now, the narrative flows smoothly once more. It is a narrative of particles and fields, of temperatures and densities. It may not be a story of human drama, but it is the story of our universe, told directly and without embellishment. It is the purest form of truth we can access from that distant frontier, and our ability to receive and comprehend it is one of the crowning achievements of our civilization. As we conclude, let us hold in our minds the image of this solitary traveler. It is a testament to what we can achieve when we are at our most curious, our most collaborative, and our most daring. It is a piece of humanity, a fusion of our intellect and our ambition, now sailing on a journey that will last for eons. The strange signal was a brief and poignant reminder of the fragility of that existence, and its resolution was a celebration of the strength of the bond that still connects us to it. It continues on, a silent pilgrim on a cosmic sea, its voyage a quiet but powerful statement of our own reach for eternity. The sound of Voyager is now the sound of clarity. It is a single, clear note of data played against the grand cosmic symphony. That note almost went out of tune, but it has been carefully and lovingly restored. Now it rings true, a tiny but perfect contribution to our understanding of the whole. Its song is one of perseverance, a melody that has traveled across the solar system and is now echoing in the vast, silent cathedral of interstellar space. It is a song of a journey, a song of discovery, and a song that tells the story of the remarkable machine and the remarkable species that sent it on its way. The strange signal from Voyager 2 was not, in the end, a message from an alien intelligence or a sign of some new exotic physics. It was something quieter, more intimate, and perhaps more profound. It was the sound of a machine, our machine, aging gracefully and calling home for help. It was a test of a bond that stretches across the solar system, a test that we and our creation passed. The meaning of the signal lies not in what it was, but in what it inspired. A beautiful and successful demonstration of our ability to solve problems with intelligence, patience, and care. We are the children of Stardust, and in Voyager, we have sent a piece of that stardust back out on a journey of its own. It is a messenger, carrying a record of our world and a suite of instruments to taste the galactic winds. The strange signal was a momentary faltering of that messenger's voice. Now, the voice is restored, and the message continues. It is a message that tells us that the space between the stars is not empty, but is a vibrant and complex place, and that we have the power, however limited, to reach into that place and begin to understand it. The odyssey of Voyager 2 continues. It pushes ever onward, a silent testament to the enduring power of a well-posed question. It is the physical embodiment of our curiosity, a tiny, remote extension of our own desire to know what lies beyond the next hill. The strange signal was a challenge to that desire, a reminder that the path of knowledge is never easy. But in overcoming it, we have reaffirmed our commitment to the journey. And so the probe sails on, leaving our solar system and its momentary troubles far behind, its sights set on the endless, open road of the galaxy. So, when you next look up at the night sky, remember that it is not empty. It is filled with the faint whispers of distant stars, the echoes of ancient cosmic events, and among them, one whisper that is our own. It is the faint, steady signal of Voyager 2, a message of perseverance from the interstellar dark. That signal, which briefly faltered and then returned, is a quiet monument to the best of what we are, and the grandest of what we can achieve when we work together to explore the vast and silent universe that is our home. The signal was now clear, the meaning is now understood, and the journey continues. The strange signal from Voyager 2 was a brief, challenging, and ultimately beautiful chapter in one of humanity's greatest adventures. It was a testament to a machine, a team, and a species that, despite being bound to a single, pale blue dot, refuses to stop reaching for the stars. And in that reach, in that relentless and hopeful journey into the dark, we find our own most profound and enduring meaning.